Welcome back to AutoTechNick. Now we're continuing on our major service on this 1997 Ferrari 456, and today we need to work to replace the timing belts, replace all of our cam seals, but more importantly, install the new timing belts, tension them, and degree them. We have a lot of work ahead of us today, a lot of technical details to cover, so let's just jump right on into it. Okay, so here is our starting point, which is where we essentially left off on our last video, which on our last video I covered all the work to get the engine torn down to this point. So removing the intake manifold, getting the valve covers removed, getting all of our ancillary belts off, timing covers off, and I even talked about checking and adjusting our valve lash, setting our specific timing clearance on our front cam lobes up here. And I didn't talk about it much, but I did go through, do my pre-service cam timing checks, checked my belt tension, really got all my documentation, information, and numbers on the engine to get it to the point now where I'm actually ready to remove the timing belts and get into the meat of this service. So if you guys are interested in to see the work that it takes to get to this point on the engine, be sure to jump in my playlist and check the previous video on the car, and I cover all of that in detail for you. So before we just jump straight into it and remove these timing belts from the engine, there's a couple things that I wanted to talk about. Now the first thing that I want to talk about is engine position. So I currently have this engine sitting on top dead center, cylinder number 1 compression. Since I did my pre-service cam timing checks, I can use multiple ways to verify that's where I'm at. I have my degree wheel proving that. I also have my TDC gauge right there showing 0. But if you don't have that tooling hooked up, you can get a rough idea of where it's at with our camshaft assembly marks back here on the back side of the camshaft to the cam cap. And you can see on this one that it doesn't line up quite as well as our intake camshaft. That's something that we can talk about a little bit later on, but I only use these marks as like a rough guideline. I do not consider these to be precise and accurate, as evidence right here on our intake cam of bank 2, and you can see here our exhaust cam lines up quite a bit better. So all of our methods that we have here are telling us we're on top dead center, cylinder 1. Now, I do that because it's always easy to get the crankshaft back on top dead center. All we need is this gauge to measure it. So if something were to move while we have the engine all apart, it's easy to return it to where it's at. The other reason is because that's the only marks I have on the camshaft, and on this particular application, I'm going to have to remove the camshafts from the engine to replace our camshaft seals. So I'm going to have to reinstall the camshafts again. And if I have the engine in any other position than top dead center, it's a lot harder to know where you're going to put this camshaft in. And since we're a V12 right now, one thing you very much so need to be aware of is cylinder 1 is at top dead center. So our piston is all the way up in top of its travel. And the same with cylinder 6. It's all the way up at top dead center. Now I'll grab my light here and show you. If we get over here and look at our cam lobes back on cylinder 6, you can essentially see that we're on overlap. And if we're to open these cams and give it more lift, we're going to cause an interference issue with our valve to our piston and cause bending a valve. Now, I talked about that a little bit when I was servicing our 355, where I was doing a 575 early on in my career with Ferrari, and I thought I'd have a better way to get the camshafts removed, so I changed my method and rotated the camshaft, reinstalled it in the engine. Well, I had the engine on top dead center, so that means I had cylinder 6 piston all the way up at the top. Long story short, I ended up bending the valves. So we have the engine sitting at top dead center, cylinder number 1 compression, which is exactly where we want, so we know we can get it apart and back together in the appropriate position. But we still have 2 obstacles that we have to take into consideration that we need to solve before we move into the disassembly. Now the first one of those is our camshaft gear bolts. We're going to need to break these bolts loose, so that way if we need to make any adjustments on our cam gears with our dowel pin for our camshaft timing, we can. Also, our crank bolt for our harmonic balancer here, if you look and get you dropped in there, you can see that there is simply no space where we're going to be able to slide these timing belts off of these lower drive gears with the pulley still in place. So we're going to need to get this bolt that's holding that on broken free so we can slide this pulley off. Now on these engines, there is no provision to lock the crankshaft in the position or the camshafts. Really, it's up to us to figure out how we're going to get this accomplished. Now on our 355 series of videos, I talked about it because we had essentially the same obstacle up here on our camshaft gears. And that's where I use the business cards on the camshafts underneath the cam cap to lock it down. So you can see I have 2 per camshaft, a total of 4 on this head. It's 1 business card. I tear it into 4 sections and I put them in there and I tighten these caps down just by hand so I can get a good feel. And basically this business card is taking up what oil clearance we have in the camshaft, effectively seizing the camshaft inside the cylinder head. Two business cards, or two pieces of business cards, I should say, on one camshaft is going to be enough to allow me to put a wrench on here and break away my 100 Newton meters torque on this bolt and also retorque it back on reassembly. Also, there's an added benefit of these, and that's once I remove the timing belt from the engine, my camshaft's not going to rotate, which is important to note back here on this cylinder 6 because our valves are actually pretty close to the piston, and we want to have a little bit of control of the camshaft once we take this timing belt off. So those serve two purposes. And that works great for the camshafts, but that doesn't really help us out very much for the harmonic balancer. Some would say put an impact gun on here and zip this bolt out, but you can see that we actually don't have very much space in here, and I will note that I actually have the radiator out of this car right now, so I have far more space and visibility than you normally would to do this job. But this right here, this electronics in this box, you're not going to get that bolt out with an impact gun. But more importantly, if you were to take it out with an impact gun, that does solve your problem. You can get it apart. But you're not set up for success on the tail end of the repair because you're going to need to torque that bolt back in. And I don't know about you, but I'm not torquing that bolt with an impact gun. I'm going to use a torque wrench and torque it to spec, meaning I need to find some other method other than an impact gun to hold that crankshaft in the position so I can get that bolt on and off. So to show you how I overcome this obstacle, I raised the car up and I brought you guys down underneath. And we're sitting back here at the rear of the engine where the bell housing would be. Now, if your car is a 6-speed or a manual, you have it pretty easy. Once you remove the heat shielding and our aluminum cover here on our bell housing, you're going to be able to see your clutch pressure plate sitting right in this area. We have a GTA here, so if I get the light up there, you'll see that we just have a big void. For a manual car, you're going to have your pressure plate sitting there, and there's very large windows in that pressure plate. So what you're able to do is get a very large pry bar, and you can slide it up into those windows of the pressure plate and use this edge of the bell housing. Actually, you can use both sides during tightening and loosening, and that will allow you to hold the engine in position. It's going to take another person, so you can have somebody run the wrench on the engine to loosen and tighten that bolt, but you don't really need any special tools. It's pretty down and dirty. It just takes two people, and it doesn't really damage anything. Now, since we have a GTA, we don't have it so easy. Now I'm going to start right here by pointing out these teeth on this ring. This is our reluctor wheel for our crankshaft sensors. This is a no-go zone. This is only pressed onto the flex plate. It's not bolted on, it's not welded on, it's not pinned in position. It is on there just with the press force. So if you put something up here and you try to hold on one of these teeth in the same manner you would with a manual onto this bell housing, you run the risk of either spinning this or having this slide off. I can tell you that I have had to replace one of these years ago on a 456. This was slid off. I have no idea why. That's why the car came in the shop. And what I ended up finding on that car is I was losing crank signal above 3,000 RPM. And I found that one side of this reluctor wheel was actually slid over about ½ inch, and that was the cause of the problem. So, no-go zone. We don't want to touch that. Really, the only thing we want, or we can lever on, is our teeth here for our ring gear for our starter. However, you can see them pretty easily right here from this view, but actually they're back behind the oil pan. So my solution to overcome this is I invested a little bit of time and I worked up this tool right here where I can bolt this in position and hold everything, lock it in place, and it allows me to get the crank bolt torqued and loosened with just me here by myself. So this tool sits right up off of these studs right here. And you can see that I built this piece up here and it's adjustable, and this piece is meant to wedge in between this opening into the bell housing here, so that way when the engine's trying to twist, this piece right here is catching this flat, and all of the torque and pressure is going through this tool in the flat, keeping it off these very small studs. These are just locating dowels. And this piece right here is just off of a generic flywheel holding kit that I bought. And you can see that I just went and welded up a piece of metal on there, so I'm going to put it in position. It has all the adjustability I need, and this will hold it in place. So clearly I invested some time in building this tool so that way I can overcome this problem. Without building this tool to do that, I'm sure you could try to find a way to get a pry bar up on that ring gear and hold it in there, but it's awkward and cumbersome, and it's probably going to create some problems for you, potentially mar some things up, to where for me it really wasn't even worth it. I just invested the time to build the tool to get this held in place. I need both hands to get this installed. I'm going to set you guys down real quick. I'll get this set up on the engine so that way you guys can see what it looks like all installed. Alright, so you can see that I got the tool installed. Pretty simple, pretty self-explanatory. Now the reason why I have holes on either side is because I designed the tool so when I lock it in position that the crankshaft's going to want to kind of wedge the piece that's going into the starter ring gear. It's basically set up so it's wedging into the bell housing here and the tool itself, so that way it doesn't want to rotate. Really, this bolt right here is only keeping everything honest. The tool is, I tried to design it essentially so it naturally wedges itself in the position. Again, with these bolts here and that plate on top, I want all the load to be transferred from this tool that's in the teeth of the ring gear into the side of the bell housing right here, and it also hits the side of my tool right here, and then via that plate up top transferring everything over the side into the bell housing. Really not putting any load on these small studs right here. That was really my main goal. Pretty down and dirty, but effective. You can see up there it clears my reluctor wheel, so we don't have to worry about that. And it's hard to see, but it's fully engaged into the starter ring gear. So that's my solution, and now I can get the crank bolt off. Alright, we got our crank pulley off. You can see I took off my pointers as well that I was using for my top dead center marks just to get them out of the way. We cracked loose all of our cam gear bolts. So now it's time to loosen up our timing belt tensioners and get these timing belts off the engine. So to get these tensioners loose and the belts off, we're just going to loosen up the 19mm on the tensioner. So with our tensioner bolt loose, if you guys see this big Allen bolt in the bracket right here for the AC compressor, I can actually get the flat of my pry bar up on there, and yes, I'm prying on the belt, but we're not going to be reusing it, so it's fine. But I'll actually pry my tensioner all the way to its end stop and come back and retighten this bolt here. That way it stays in position, and now I have all the slack I need to work my timing belt off the engine. Like so. So it's pretty much the same thing over on bank 2. So we now have the belts off. We're just going to leave our tensioner bearings in that position. We'll come back and address those later. Now we're going to focus our attention to getting the cam gears off. That's going to allow us to get this shielding off as well. Now, one word of caution, these cam gear bolts, they have the O-ring on the back side. That's because the camshafts are hollow. The camshafts actually help feed and distribute oil within the cylinder head. So when I remove this bolt, oil is going to come leaking out. How much oil leaks out will be dependent on how long the car has been sitting since it last ran. This car has sat for a little while, so there won't be a ton of oil, but what I will do is I'll take my pneumatic vacuum there, and once I pop this bolt out, I just run that hose in there and try to suck out as much oil as I can from the get-go. And that's because I'm picky, and I don't like the camshaft just continuously dripping oil down on the front of the engine. You can also see the last person that did the timing belt service marked all the cam gears, so bank 1 intake, bank 2 exhaust, bank 1 intake, and deductive reasoning, we know that's bank 2 exhaust. I like to mark the cam gears in the same fashion, however the only difference is I like to remove my marks when I'm done with the work. So we'll just leave those marks on, they're sufficient for what we're doing, and then once we reassemble the engine, I will wipe all those marks off so that way there's no traces that we are in here. So let's get these cam gears and rear timing covers taken off the engine. So before you just remove your cam gears and your dowel pins, you want to take a second and mark your cam gear on which hole the dowel pin is sitting in, and then try to make a corresponding mark on your cam shaft so you know where everything was set up before you took it apart. This kind of comes into play where we did our pre-service timing check, so we know that our cam timing is pretty accurate with these particular settings. So I'll take a minute here, and I'm just using a little paint pen and leaving a mark on the cam gear and the cam shaft. So that way now I can remove that dowel pin, I can remove this cam gear, As long as I get this cam gear back on that camshaft and that dowel pin on the same hole on the camshaft and the cam gear, I should be very close when I go back to retime the engine. Now you'll notice over here on the intake camshaft that it has an existing mark from the last time it was worked on, and that was presumably a mark that he had when he took it apart. And you can see once he went and put it back together, he ended up making a change on his camshaft timing, moved his dowel pin over. I've covered it. I'm fussy. I don't like leaving my marks, and that's kind of one of the reasons why, because they have to come off anyways down the road. So it's pretty easy to get rid of them because camshafts are nice and oily. You can just kind of scrape them off with a pocket screwdriver. Fortunately, these paint pins aren't that great. They're good, just good enough to get these marks on there. So I'm going to go back and make marks of my own where it was set up. And as I've discussed, I will take all these off when I'm finished. That one's on spec, so we just need to make one more here. So we're just going to take a minute, get everything marked, use all my colors so I know. And that one's not marked at all. Keeping consistent with everything, just like so. So now we know all the position of the cam gears to the respective camshafts and how everything was set up. So hopefully upon reassembly, our camshaft timing is going to be a lot closer and save us a lot of time working to get the cam timing set in spec. Now we can work our cam gears off, and we can just wiggle them. I just leave the dowel pins in them, and they'll come off right there. Pretty straightforward. You can see my little cardboard in the valley of the engine really comes in clutch here. You can work those off. And now we can work these off. Our timing covers. And we're going to set these aside on the bench. And do not forget these on reassembly. I can't tell you how many cars I've set timing belt tension on, go start degreeing the camshafts. I think I've even gotten through degreeing the camshafts. And I go to my table of parts, and you have new belts on and everything degreed, and you see these sitting here. Absolute kick in the nuts when you see that, because you have to go through and redo all your work. So do not forget those covers. Set them in a place where you're going to remember them. But now you can see that we're down to our camshaft seals. This is where this job gets a little bit different versus the 355 that we last serviced. On that 355, we actually had two small 10mm nuts down here on these flanges. We could take those off and slide these cam seal plates forward, and that was going to allow us to replace this camshaft seal here and these O-rings. However, on the older cars, and Ferrari's infinite wisdom here, grab my screwdriver, and it's hard to see because we have so much silicone in there, but on the 355, this head is machined on this plane right here where my screwdriver is at, straight across. And there's actually a bigger gap around this aluminum plate and just the O-ring is sealing. You can see here that it's very tight, and essentially is what we have here is we have the main surface that's machined, then they machine a groove in for the O-ring. So essentially this section right here is prouder, and because we have that, we have the O-ring setting inside a groove inside the cylinder head. Because of that groove, we cannot slide this plate off. We have to remove the entire camshaft to get that out of the head to get it removed. So I guess it looks a lot like that back there. You can see how the rear plug is where it has that groove for the O-ring. So this is how the older style is. I believe off memory the 348's the same way. That's kind of where I was saying the bulk work of these timing belt services is very similar amongst the cars, but there's differences that make it different in the end. This is one of those things on this particular car. And also, fun fact, even if I didn't have this metal here that's trapping my O-ring into the head, this plate won't fit over the edge of the camshaft anyways. So there's no way that I can get this off going forward. I have to remove all of my cam caps, get the camshafts out of the cylinder heads, then I can take this plate, slide it all the way down off the back of the camshaft. As for removing the camshafts, there's no good way about it. You have to slowly and progressively loosen up your cam caps until the camshaft comes up, and I just try to do it evenly so that way the entire camshaft comes up at an even plane, so that way I don't have it bolted all the way down in the front, loosened all the way to the back, and then I have the valve springs pushing it and putting a load on it. That's what I try to avoid. I start back here. I want these lobes to move away as quickly as possible because our piston's at top dead center. We have our business cards to help hold everything true. So I just kind of go back and forth, work them slowly, get the cams lifted out. I will move all this stuff here back to my workbench so that way I can set all my cam caps and my magnetic trays to get all my nuts and washers. And essentially I'm going to work through to get both camshafts on both heads, basically all 4 camshafts removed from the engine. Now if we jump back to the previous video when I got the engine disassembled, I talked about the fact that I don't go all in on cleaning the cylinder heads at that point to get the gaskets off the rails. That's because I wait till once the camshafts are out, because I'll have so much more space to do so. In order to move forward on this timing belt service, we have to spend some time cleaning, prepping, getting all the silicone off, so that way we can get all these new gaskets in these cam seal plates and the camshafts reinstalled into the cylinder head. So you can see that I'm just loosening these up just a little at a time. This method is not super scientific. It just takes a little bit of caution and diligence, paying attention. And one thing to keep in mind, that if you have a lot of pressure pushing up on the cam, say right here on this cylinder, on cylinder 3 on the lobes, that there's going to be more pressure on these caps. So once the nut comes off the cap, there is a washer behind it. So you want to be sure that you're aware that that's about to come off, because you don't want it to fling that washer into the engine. We have a lot of open ports here on the engine, so obviously the last thing we ever want is that washer or that nut falling down into the engine. It's really take your time, be diligent, be careful. I usually will keep my hand on the hardware here, so that way if it moves, I can capture it. All right, so a lot of these are loose, and that's because we don't have much pressure on them, and I don't want to loosen those anymore. Is what I'm feeling for is my tight ones here, which is these 2 caps right here, because these cams have the most lift on it. So we're going to slowly bring those up. And now these nuts are free to spin, but that one's tight. So we're just basically transferring which cap is too tight. So now we're on these 2 outers. And be careful of this hardware. You don't want it to shoot off, because there is a little bit of pressure on the cap and you don't want to lose it or have it fall into the engine. So we're just running through. This one's pretty loose, so I'm taking off the nut and washer now. We're going to switch to our hand ratchet for these last ones, just so we have a bit more control. We don't have any surprises. And our last one here. There we go. And all of our cam caps are numbered, so we know which cylinders they go to, but I just set them up here in order, and I leave them up here throughout all of the time that the cams are out of the engine, just to minimize moving them around, a way to be sure that I don't get them mixed up amongst each other. So we got those there, cams free, and we can pop our camshaft out, and our O-ring is glued into the head. There we go. And now that we have this out, I should be able to show you our cam seal. You can see that we can't get it off the front. So cam seal and plate, slide it all the way down, and we're going to set our camshaft on our bench. Okay, so you can see, just a little bit of patience, you slowly work all the hardware off, the camshaft will come out. But now that they're out, you can see how much more space we have, and we don't have to work around the cam and the cam caps. That's why I wait until now to effectively come through here, clean all of my silicone off, clean back here on the back of the head, because I just have much more working space. It's just a lot easier. And you can see up here, we're going to have to clean all of this sealant out, which is not a big deal. That's all very normal, part of the process. When we pulled the valve covers off, we did notice that some of the valve covers, or at least bank 1 valve cover, was staked where the gaskets don't slide out. But I have noticed since then that the cylinder heads don't have those stake marks, and also the valve cover on bank 2 didn't have any at all. So we're going to go through and revise all that, where we make our punches here, and that's going to help bite in and hold our valve cover gasket in place so it doesn't slide out. Also, I have talked about, we want to make sure these holes here for the O-rings are chamfered. These ones have a slight chamfer to them, but if we look at our old O-ring, you can see where they're starting to kind of get into it and bite into it. So they're not chamfered enough to prevent this from happening. So we're going to come back through and rework these as well. And now that we have this cam seal plate out of the cylinder head and the camshaft out, we can see a lot better the groove that I was talking about that kind of captures it in there. So it's really this extra metal right there that's preventing us from having the ability to slide this plate forward. Now, the 355 uses 2 ears with some bolts that hold it in place, so that way it can slide in and out. And that's really the main difference why we have to remove the camshafts on this 456 as opposed to the 355 where we don't. I believe, going off memory, a 550 is the same way. and the 575 and 612 have the same style as the 355, where we don't have to remove the camshafts to remove these plates. Just one of the quirks and differences of the cars. It creates, I guess, a little bit more work, but it makes it easier to clean everything. A little bit more risk, like we mentioned. Got to be really careful that we don't bend a valve going back together. So my plan moving forward here is to remove the other 3 camshafts. Then I'm going to spend a little bit of time cleaning up my valve cover rails, get all the gasket material off, get all that silicone off. I need to go through and make those changes that we talked about for the O-rings. I need to stake the rails of the cylinder heads for the gasket. And if I also bring you guys back here, I haven't done anything with our valve covers at all, so I need to come through and get all this old gasket material and silicone cleaned off, get all that taken care of, get all of these out, all the silicone cleaned off of them, get new O-rings on them. Again, we need to make all the same modifications to the valve covers. That's what we're talking about right there, those small little peen marks. I'm going to hit these ones again because they seem a little shallow, but if we go to the bank 2 valve cover, it does not have any at all. They just did it on the bank 1. So we're going to go through, make that all uniform, consistent and the same, and then once I'm finished with that, I'll bring you guys back because we'll start working towards the reassembly. All right, we're back. Yesterday we made really nice progress getting everything cleaned up, prepped, and modified, essentially getting everything ready for reassembly on the engine. Now, I will say when I'm doing these timing belt services, once I get to this point and I have everything torn down, I usually like to just invest the time up front and get everything clean. So I'm talking get everything cleaned on the cylinder heads, get all of our modifications done, get all of our cam seals replaced. Then I jump over and deal with things like our valve covers, get those modified, get them cleaned up. Our timing covers, all of the plastic covers for the front of the engine, those as well. Really, my goal is to go through and get everything cleaned up, new gaskets and sealed installed, all the old silicone and sealant cleaned off, all the modifications need to be done. I really want everything essentially set up so that way when I'm working towards reassembly, I do not have to stop to clean anything or prep anything for reassembly. I usually find that if I just invest all that time at once, I'm doing the same kind of work. It's really just tedious grunt work. It will make the reassembly go much quicker, and in my opinion, the workflow of the overall project is a lot quicker. You'll notice that we have the head fully cleaned, and I still have the cams out on this side. I've gone through and made my bevels or my chamfers here where our oil rings and the cam seal plates go. And you can see that I did my punches here on the rails of the heads. That's going to help hold our gaskets in place. And you can see I did it back here at the back of the engine too, which getting these done on the engine's pretty easy. Back here, I'll show you the file I use. I actually use a smaller file versus the regular one because although it looks like you have a lot of space, you really don't have much space to work these to get them filed down. But we got that taken care of. And you can see that without the cams or cam caps on, we have a lot more access. So I'm able to come through, get all the gaskets scraped, cleaned off. Anything that falls in here, I'm able to get it cleaned out so it doesn't get stuck into the engine. And really getting ourselves set up for reassembly of the engine. Bring you guys over here on bank 2, and you can see that I've already gone all the way forward and put the camshafts back in. So they're set up on our cam caps on our timing marks for top dead center. We have the new O-rings in our cam plates, new cam seals in the cam plates. Again, these have to be installed with the camshafts, so they're installed into the heads. Cams are in, business cards holding them in place, cam caps torqued down. So that's pretty much set and ready to go. I did that just because I was cruising through the workflow, making good progress. There is a couple things to talk about before I install the camshafts, but I'll show you all of that over here when we do bank 1. And I'll bring you guys over to the workbench, and really a lot of the same. You can see the valve cover is cleaned up. I've gone through, did the same stake marks, all of our chamfers we talked about, made all my modifications. You can see that the valve cover is clean. And like I was mentioning, we're in the cleaning mode. I'm going through all the work, getting all the oil off this, all the gaskets, the grime, the dirt. Same thing with all of our timing covers. So I spent quite a bit of time getting these cleaned up, especially the back side. Just really tedious, time-consuming work, but it makes it a lot nicer because now when I'm working towards reassembly and I go and grab these parts and all the hardware, it's already clean, it's already ready to go, and it really makes the reassembly come along a lot quicker on the car. I kind of discussed it earlier, mentioned it, and we have our cam seal plates. I've already cleaned them off on the back side, got the silicone off, our O-rings off, but I left this front seal in so I can show you how I get these out. Now I'll do my best to show you guys this holding the camera in a hand, but you can get a screwdriver back in here and underneath the seal and right on the outer edge of the seal, but you're kind of limited on the angle you hold the screwdriver at, and I usually just put the screwdriver in like so and drive it out with a hammer. Now you can see that we have maybe 1/8 of an inch of lip right here of the aluminum housing to where the seal is at. If you don't have any special tools or really anything better to hold this, you can set this on a bench vise if you open it up and position it just so the edge is grabbing this aluminum and it's not over on the seal. And then you can hold your screwdriver in like so. And I usually you can use a hand and I can hold the seal like this in place with the screwdriver and hit it out. Now, the problem with that is it's not held securely in the vise, so it can slide, it can mar up the surface, and it's really not the best way to do it. I don't like clamping this piece in the vise because, again, it's going to mar up the outside of it and potentially deform it, which is the last thing we want to do. I've made it easy on myself, and I just have this sleeve here that's part of a generic bearing press kit that I have. And if we size it up on here, I'll show you. You can see that this sits right on the aluminum housing and gives plenty of room for the seal to come out. The only problem with this is you can see that it doesn't fit very well and it's hard to hold this in place. So I just use a silicone coupler that's hose clamped on. I set that in there. I can tighten my other hose clamp, which I'll need to set the camera down to do. The whole purpose of this is it holds it in place. You can see that I have plenty of room for the seal to come out, and I'm not chasing this around while I'm holding the screwdriver in the right position. Because of the angle the screwdriver is at, it's kind of awkward to knock it out, and sometimes if you don't get enough depth in the screwdriver, it'll just go straight through the seal and it won't push the seal out. So it's really important that you have this all the way out the outer side of the seal pushing up into this corner, not out here in this inner part. And this tool makes it a lot easier for me to be able to hold the screwdriver where I need to get the seal knocked out. I will set you guys down, get these seals driven out to show you how it works, and then we'll continue to work forward on getting these seals ready to go back in the car, because there's still another thing we need to consider before we put them on the camshafts, and the camshafts in the engine. Alright, so our seal is in, and we're just going to tighten our clamp down so that way we don't have to worry about this moving too much. And again, we're getting our screwdriver in, moving the inner lip out and getting it as far on the outside of the seal as I can. Hold it up. And a good drive. You can see we got it in one shot right there. Spinning in a little bit of time to get this, so you're going to hold this easily while you drive the seal out. Really makes a big difference. It doesn't mar up our plate, doesn't cause any damage. It's quick, it's down, it's dirty. And like I mentioned, worst case scenario, if you really had to, you could find two things to set the seal on. The teeth of a bench vise works. You can drive the seal out, but there is a bit of a learning curve with that, where this will want to slide it around and move with holding everything together. I'd suggest finding something like this if you want to get the seals driven out without any marking or damage to your plates. So I'm going to get the other one driven out, get all these cleaned up. I need to get my new seals and O-rings back on these plates, and I'll bring it back to the engine. Okay, so we have our cam seal plate with a fresh cam seal. You can also see we have a new O-ring on the back. It's all cleaned up and all the silicone is off of it. Now what I want to talk about is this little groove that you'll see that's machined here on the back side. Now that groove is an oil return groove, and it's meant to match up with the oil return we have here on the cylinder heads. You can see that I put a little mark here on that one. We'll need that here in a second. Is what happened on the early cars is they did not have this groove right there, and the oil tends to pool up back behind that seal. You can see it's got this cavity because the diameter there of the seal is greater than the diameter here of the aluminum. So the oil would pool up in there, and then it would have a tendency to leak out of the front of the camshaft seals. So Ferrari's solution was to go through, and we actually on some of the early cars have to add these slots into them. Actually on some other cars as well, these holes are drilled in the wrong spot, specifically the older 4-valve V8s, where we have to go through, re-drill those drain holes with a special fixture. So this has kind of been a common problem. Depending on how the car is set up, these cam plates take a little bit different considerations when you're installing them. So far on this channel, the last car that we did a time belt service on was a 355, and those cam seal plates bolt on with 2 bolts. They have 2 grooves, one on either side, and that's essentially because with the 2 bolts, its index, it can only go on one way, and it has the grooves depending on which side of the engine you're putting it on, so that way you always have a groove lining up. We really don't have to take much into consideration when we're reinstalling those. We, put on the new O-rings, put in our new cam seals, make sure we put some silicone on there, install them, and we're good to go. On this particular 456, 550s are the same. We need to go and be sure that we orient this groove to match up with the drain on our head. That's where I set this mark in here, because the drain hole is pretty tight down there. But we're going to need to be sure that when we're fully reassembled with the car, that we have that all lined up. But as you can see, when you have the camshafts in, you can't see those marks at all. You have no visibility to it. You need to find some way to be sure that this is indexed correctly when everything's assembled. And remember, this slides on the back side of the camshaft, and we seal it up with this 1211 sealant on the bottom side, so once they're installed, as these ones are, I can't rotate them to make any adjustments because I'm going to break my sealant because it's already cured essentially since I did those yesterday. So we need to find a way to get these installed with the camshafts, but be sure that we have our oil drain in the correct location. Now on the top of these, there is a stake mark that Ferrari did put in them, which is 180 degrees away from our groove, and I will get these both in place on the head for you. We'll set the valve cover on, and I'll show you the relation of those stake marks. So you can see that I have the cam seal plates in, and you can see our marks where our drain holes are. And if we bring you up over here, now that the valve cover's on, you can see that there's a corresponding mark that goes to our etch on the cam seal plate right there that helps you index where they need to be. My valve cover's not sitting all the way on, so they're not lined up completely perfectly right now. But if you come down to the exhaust cam side, you can see that our marks do not line up. And that is because the oil drain hole in the cylinder head's not drilled at the bottom dead center point of this cam tray like it is over here on the intake side. So if we rotate and make our marks match up, now the trough of the cam gear is at the bottom dead center point, and you can see it's just a little bit off to where the drain hole is on the head. I'm okay with this setup being like this because it's still getting the oil away from the cam seal, and then it's going to want to get back here to the drain rather than moving it over a little. I just feel that that's going to cause a little bit more oil to collect here on the front side. I don't really care how much is collecting between the cam seal and the head. I want the oil away from the seal itself. We want to have this on and index correctly to these marks. I mentioned that I use this 1211 sealant on the bottom side of these cam seal plates when I install them, like those ones already have. You can see maybe a little bit of it there, and I've already gone through and cleaned up the excess. That poses a bit of a problem on assembly because once we install the camshafts, we still have a lot of work to do with getting our timing belts on in tension, our cam gears on, everything degreed before we can actually put the valve covers on. And that creates a problem where How do we know where to set these cam gears at with the valve covers? One way is we could go forward, install the camshafts with the gears while the silicone's still wet, set the valve cover on, make sure they're indexed correctly. However, I have another technique that I use to set these in place so I know they're in the position I want them to be in. Okay, so here's my technique to getting these oriented correctly so that way I can install the camshafts with sealant on them and not have everything have to be disrupted or moved once we put the valve cover on. Essentially, I'm going to have a method to get these installed and indexed without the valve cover with these marks up top. So you can see that I have them sitting in place. We just had the valve cover on and we lined up the marks on the back side. So we know that right now they're in the correct position where they need to be. Because what I will do is I need to come back and make some marks on the back side where the flat of the cylinder head meets the back side of these cam seal plates. And those marks are going to help me get the camshafts in, the seal plates on, make any movement or adjustments that I need to, so to be sure that they're indexed correctly. And then that way I can let them sit in position while the silicone cures. When we get to the point where we get the valve covers put on, they won't need to be moved and they're in the correct position. So I'll set you guys down, we'll make our marks, and I'll pop these plates out so you can see what I'm talking about. So I'm just pushing down on the plate so I can compress the O-ring as much as possible and just make some quick little marks there. Do the intake side, and we'll mark them. And now you can see our marks right there. So when we put this in with our camshaft, we know if our marks end up like that or like that, we know that we just need to rotate our marks so they line up and they're in the correct position. Now that those are marked, we know which one goes on which side. I'll come back, I'll clean up the Sharpie that gets on the cylinder heads. Once I put these in and they're in position, I come back and clean up my marks the best I can. But that's my trick, getting your cam seal plates indexed correctly for the oil return drains. Okay, so we have the intake camshaft here, and we're just going to set it into the cylinder head without our cam seal plate on it for now. And we're going to look for our mark for the top dead center to match our cam cap, which is about right there. So you can see right now it doesn't even want to sit in that position, and then if I rotate it, it actually sits quite nicely into the head, and that's where it wants to rest. So this brings me to a story of years ago where I was trying to find a better way to do this, and it ended up really biting me in the ass. I didn't like the fact that we have to run the cam caps down to run the camshaft in. So if we have the cam in this position, you can see that I'm rusted in the journals of the cylinder head. But back here at the back, I am a ways off. I am probably 3/4 to an inch off. And it's all because it's pushing down on the lobes right here on cylinder 3. Basically the cam's rocking on those lobes. If I set the rear all the way in, you can see it's teetering on them. What we have to do to bring this camshaft in, since there's no special tool to compress the camshaft evenly all the way in, is we have to run the cam caps down slowly, walk the camshaft in, which is theoretically going to put a little bit of bend in the camshaft, which I didn't really like. I wanted to avoid that because, well, camshafts aren't made to have a bend in it in that direction. My thinking was, when I was doing this particular 575, is we can see if I take the camshaft and rotate it right here, it nearly sits all the way into the cylinder head. So it's sitting flush, and I can actually, if I take a rear cap, set it on for you, you can see that I can almost get my nuts started on that rear cap right away, versus if I go and do this on the top dead center mark, you can see that we're a long ways away from getting those on. So that was my train of thought. My train of thought was the cam wants to sit here, so I'm going to set the camshaft in here, get my caps on, and then I'm going to rotate the camshaft once it's in to where I have this top dead center mark up here, and we should be good to go. Well, the problem is, if you look at the lobes back here on cylinder 6, when the cam wants to sit normally, those lobes are opening the valves. We discussed it when we pulled the engine apart. Cylinder 1 is at top dead center. The piston's all the way at the top of its travel. So is cylinder 6. It's at top dead cylinder also. So is what happened when I did that is I actually had the camshaft in this position. I did not use power tools. I used this small ratchet, tightened it down by hand, rotated it in the position. I thought everything was fine. Ran through my cam timing, got the car up and running, and the car actually did not run very well at all. Basically had a dead miss. So I was only running on 11 cylinders. And long story on that, I have right here the 2 valves out of that car. When I ran the camshaft in, I actually ended up running those valves into the piston. I bring this up because I was being careful using a hand ratchet. My train of thought was I'm gonna be able to feel if there's any resistance or anything wrong as I'm running the camshaft down. And I did not feel the heads of those valves getting bent with a 1/4 inch ratchet. I mean, if I was using a power tool or, you know, something more aggressive where I don't have that feel, I could maybe see how this happens, but this was so subtle, I didn't feel it at all, and I didn't know that it was a problem until I got the car running. I'm bringing this up because it's one thing that can really catch you out when you're doing this. I mean, there's not a great way to put these camshafts in the engines. You just kind of have to work them in with the cam caps, but it's really important that you have to have it right here at this mark facing up, matching the mark that's on the camshaft, or the mark that's on the cam cap, I should say. I will say that I do cheat a little bit, and I'll show you once we get there. I will set the camshaft in this position like so. I'll set the cam caps on it just to get them started. Then I'll rotate it into position and start tightening it down. I will not tighten it down in this position. I will only use this to cheat because I can get more of the cam caps on, which is going to minimize my side load. Meaning, if I can get them all started roughly the same amount, then I rotate the camshaft. The camshaft's going to want to push the valves down rather than have any deflection, which is what I'm trying to avoid. Let's move forward and get our camshaft in. We'll grab our seal plate here, which is our intake. And another advantage of the marks that we made with our Sharpie on the bottom is it's going to allow me to put my 1211 sealant on the bottom half of the O-ring only, where I won't have any on the top side because we're going to have that sealant on there once we install the valve cover. We only want it where it's going to be sealing up right now. Just a small light coat. Right there. It's probably a little bit more than I wanted, but it's what came out. So we got that there. We got our marks. We got our oil retrain hole in the bottom. I have to lift the camshaft up and out. And this plate comes up all the way from the bottom. Get it up on the top side. And set everything in place. And now I'm going to try to keep my plate in position, but I need to rotate my camshaft. There's our top dead center mark right there. It's off to the side, but the cam's sitting pretty good. I'm going to put a little bit of assembly lube. I'm going to skip the journals that I use my business cards on. Our cam caps, this is the top side. They are numbered on the head and engraved, and they're directional, so I double check that everything's right, but I place them in order so that way I have less chance of mixing anything up. And this is number 2. And these ones, we'll slide our business card in, and that's going to keep our camshaft from rotating. Like I mentioned, the camshaft is in the wrong position right now, to where we could potentially bend valves if we tightened it down to where it's sitting at. I have it in this position and grab our hardware here so we can get it started, and then we'll rotate it. The more cam caps I can have on right now, the better. So I'm only just starting these nuts as little as possible, so that way if the camshaft needs to lift the back end up as I'm pushing it in so it levels itself out, it can. I don't want to suck these cam caps all the way down and have the camshaft sticking up on the back side. It's starting to get raised up here at the back, so we can fit our washers on most of these. And I don't think I'm going to fit washers on this cap, so we're going to skip the washers and just put the nuts on. And we'll come back and place our washers on it once the camshaft's in position. We can pop one cap on at a time, or pop one cap off at a time, get the nuts off, put the washers on, put it back on. All right, so we have the camshaft in, but it's in the wrong position, but that allowed us to get more of the cam caps bolted down to where we want them. So now, before we start bolting down the cam caps, I want to rotate the camshaft in the position that it needs to be in, so we don't bend valves on cylinder 6. You can see on cylinder 1 our cam lobes are up, so we really don't need to worry about it. Our cam lobes are down on cylinder 6, so those are the ones we need to worry about. My mark is over here on the side of the camshaft. I need to bring it up top, which is going to take my lobes away from the lifters on cylinder 6. One thing to note on these camshafts, there's no provisions to rotate them. A lot of camshafts will have flats on it, or like a hex that's cast into the camshaft, so you can put tools on there and rotate them. Ferrari camshafts do not. However, a 27mm wrench will fit nicely onto the cam lobe. It doesn't take a lot of force or effort. You can see that we're just rotate this cam in the position. Right now, I can tell you that my wrench is starting to hit the cylinder head, so I'm out of movement, but my mark is virtually lined up pretty close. So you can see now at the back that my cam lobes are off the lifters, so I'm not pushing those valves down, so there's not really much of a chance of damaging the valves or bending those valves. So now that we're in this position, I'm going to tighten down my cam cap that has 2 nuts on it, just enough to hopefully get a nut on this cap back here. now that we got 2 nuts on that cap, we're going to bring those in a little bit. From there, we can actually get this rear cap on. I'll probably get my washers on that one. I keep my wrench on here until we get the cam seated down to where the caps with the business cards have enough tension to prevent it from moving. I'm just kind of keeping it honest right now. It doesn't really want to move, but I don't want it to move on me. I can tighten down all the cam caps evenly across the entire length of the camshaft to get this seated in gradually rather than tightening them down aggressively just starting on one. So we can get our washers on this one. And I just kind of jump around so I can bring it in gradually. And again, we're minimizing that load or deflection or bending of the camshaft. And you can see that as we bring it in, we're gaining a lot of slack on these nuts. You can just spin them in by hand. I mentioned that my wrench is on the head and I'm not quite lined up. So as we're getting closer, I can see that my camshaft timing is not where I'm going to want it. Especially now that I'm tightening this front cap down, it's moving a lot. So I can actually come off this lobe and grab the lobe over here on cylinder 2. And that lets me move the camshaft just a little bit. And now we have it where we want it. Once I get one of these caps with the business card tight enough to hold the camshaft in position, pop our wrench off real quick. All right, so that cap is tight. Our marks on the camshaft are in position. I can see that I pulled my lobes away from the valves back here, so we don't have to worry about any damage up there. You can see that now we have the cam seated in there. Most of these we can run down by hand and get them tightened up. This one, we'll take our nuts off. We will install our washers. All right, so our camshaft is in. All of our cam caps are tight. And the last thing we need to do is be sure that our cam seal plate is indexed correctly. We're going off of our Sharpie marks. And you can see that it rotated on me quite a bit, so it's sitting where it needs to be. I will clean up any excess sealant on it, and we'll just leave this cam seal plate now in position as everything dries, and we won't move it. And we know that our notch up here will align with the valve cover on the final assembly. All right, so the intake camshaft is in. Now it's going to be the exact same process for the exhaust cam. And just like the intake side, I had to rotate the cam off position so it fits the way it wants. Let's give this a little bit of lube. All right, so we got nuts and washers on the first 3 cam caps. And this 4th cam cap back here, there's not enough space for washers, just the nuts. And I don't think, I might be able to get 1 nut on this cam cap back here. Be surprised if I can get 2. Oh, barely. So we got the first 3 with washers and nuts, the back 2 back here with just nuts, and these last 2 aren't down enough to get anything on them. Again, our camshaft is out of time. It's trying the same thing on the exhaust cam. It's trying to push the valves down on cylinder 6. So I need to rotate the camshaft towards me, and that's going to bring the cam lobes away and free them up. So we're going to have to come over here to cylinder 5 to get our wrench on it, and watching our marks up here again. Bring this over, and my coolant expansion tank is getting in the way. There we go. So now I got my mark lining up, my lobes are off, so I know that these lobes are on the base circle on cylinder 1 because it should be on compression, which is where we want to, or where we stopped the engine. So we don't have any worry about valve interference issues there. In cylinder 6, I can see my lobes are pointed towards each other in the center. So now that I know that they're rotated, we're good. So now we can work the bolt the camshaft down. And again, I'm getting started on this rearmost cam cap, so that way I can bring the back of the camshaft down. I'm actually noticing this cap back here, all the way at the back, I can get some nuts on it. Actually, I can get them all. I essentially have all the nuts on all the cam caps. Not all of them have washers, which is fine. We can come back and correct those once we're done. rotate our cam seal plate where it wants to be. And our camshaft's lined up where it needs to be, so I just need to work all the cam caps evenly to bring the camshaft down to the cylinder head as evenly as I can. Once it gets all the way down there, again, our business cards are going to hold the camshaft in position, and we can take our wrench off. It's tempting to just run them all the way in, especially on the cam caps of the business card, so I don't have to hold this wrench. My goal is to put as little stress in this cam as I can, bring it into the cylinder head as evenly as possible. And you can see I'm pretty much going every other cam cap, bringing it down. Come back on all the ones I skipped. Check our mark here. Looks like I'm running out. Same issue I had on the intake side. I was hitting the cylinder head. So we'll jump over here to cylinder 3 and line our marks back up. All right, that cam cap's down, so the camshaft will stay in place. I'm gonna come back now and get our washers on the caps that don't have any. All right, so we got both camshafts in, and give you guys a little bit of light. You can see that these are the marks back here that I was lining up, and we're lined up right on the money there. And if we come back here, you can see the lobes on cylinder 6. So each camshaft, like I mentioned, I set in a resting position where I could get more cam caps on versus having it in this top dead center position because the lobes are pushing up on it. In those positions, both on the exhaust cam and the intake cam, those lobes are pointed straight down. So this camera is rotated more this way, the intake cam is rotated more in this direction. I only set the cams in there, got the nuts started to hold everything in position, and then I use my wrench to rotate the camshaft. And I will say, it seems unconventional, but these lobes, putting this wrench on there doesn't do any damage to them, and in my opinion, it's far better than putting a pair of pliers on the base circle of the camshaft or up here where the cam gear goes, or prying on that. This fits on there quite nicely, and because of the shape of the lobe, it wedges itself in there and allows you to rotate the camshaft just like such. It's a good little trick. 27mm is the size. So we got the cams in. All of our cam seal plate O-rings and cam seals are replaced, and everything's good and new. To continue on with this belt service, the next steps we need to be doing is putting on our new tensioner bearings, putting our cam gears back on, and getting the belts on. However, this particular car has an oil leak coming from our front timing case cover. I actually need to go and pause on the timing belt service right now to work to get this cover off and that oil leak repaired. I think I'm gonna cover that in a completely separate video. I'm gonna work to get that timing cover off, all of my timing shafts out. I'm gonna be replacing all the bearings while I'm in there, along with the gasket. Again, like I said, I think that is a subject worthy of itself, and I really wanted to keep everything for the timing belt service all in one video here. I'm gonna make a pivot, start working on that, but I'll see you guys back here in a second once that's all back together so we can continue on with this timing belt service. All right, we're back, but now we have a freshly rebuilt and resealed front timing cover. We got all that work taken care of. It's on a separate video, and I essentially have the engine right back to where it was before we left off, with the exception of I've already gone ahead and replaced the Bank 2 timing belt tensioner pulley here. Now, I am making a change from the OEM factory pulleys to the Hill Engineering pieces, and that is because they are a much superior unit. We look right here on the bench, you can see that the Hill pieces have a much larger bearing in them versus the factory pieces. And the seals are a lot better as well, because this is a real common problem right here in the factory pieces where they start to throw all their grease out. Obviously, we don't want that grease getting on the belt, and we don't want a lack of lubrication into the bearings. Not to mention, these Hill pieces are actually cheaper. It's really a win-win with no downside or negative consequences of going to the Hill parts. It's a superior part, it's more cost effective, it can bring the cost of the service down a little bit. I'm going to work to get this other tensioner pulley popped off and get the hill piece on. I'll show you guys how we work through that. And then we're gonna move right into getting our timing gears back on in preparation for our new belts. So I mentioned it earlier, you wanna be sure you do not forget these covers. If you forget these covers before you put the gears on, you're gonna be in a world of hurt. So we have the gears, we have our dowel pins marked where they're at in the camshaft. The gears were previously marked for their location, so this one is bank 1 intake, and we have our marks on our camshaft. We're going to get the new tensioner bearing on, we're going to get our back cover plates on, then I'm going to set all 4 cam gears in place with my dowel pin matching the holes where everything was at when it was all disassembled. Now I will mention on this front timing cover, when you take these off and get them reinstalled, it is very tricky to get this all reassembled so that way your lower timing gears here are in the exact same position. So I actually went about removing and reinstalling that front cover in a different method that I've done in the past, specifically to make it easier for me to get it back together in the exact same position. I know that I have it reassembled with all the gears meshed into the same teeth and everything's indexed correctly. I'm bringing this up because once we go to place our timing belts back on, I know that my lower drive gears are in the exact same position, and I know that my cam gears on the cam shafts will be in the exact same position. So essentially I'm going to be able to get my timing belts reinstalled in the car with everything in the exact same position it was upon disassembly, which is key because our cam timing was very close on this car. Alright, so we'll work to get this tensioner off, and we're just going to loosen up our bolt. The spring is going to snap it back. And once the bolt comes out, the tensioner is actually, or I should say the spring is actually pulling on the tensioner so far that the side or the inside diameter of the bearing is actually running on the shaft of the bolt. So it's pretty tight to get the bolt out. But if we just take a screwdriver and put a little bit of pressure here, move the tensioner off the shaft of the bolt, we can spin that right out by hand. And that just makes it a little bit simpler, easier, and quicker. So we're going to return to that to the position, and these are a semi-tight fit pressed onto the shaft. Fortunately, that one just slid straight off. So a lot of times you can pull these straight off just like I did. However, on this particular car on bank 2, I was not able just to pull it off by hand, and rather than trying to use screwdrivers and kind of pry or wedge it off, and it gets kind of cumbersome and it gets stuck on the shaft, I just use this 2-jaw puller, and honestly I can put this puller on the back side of the bearing like so. This fits right on the front side, and I only need to tighten it with my hand. I don't even need to use a wrench, and it'll pull the bearing off. And I usually just go to this if I can't pull the bearing off by hand, because this just makes it so much quicker and it's that much less fuss. So we got that bearing off and out of the way. Get everything cleaned up. And there's really not a lot we need to do to these tensioners. They are a mechanical type, so there is a spring on the inside in there. That spring doesn't really need any servicing. If it had a problem, we would feel it based on the tension when we're moving this tensioner. This tensioner, once it's set and locked in place, there is no movement for the tensioner. It stays in that position. Now these hill tensioners are directional, where there's a recess where this special washer fits on the inside right there. And this washer has a little ridge on the inside. So you want to be sure that you're putting those on in the correct direction and orientation. Get the rest of our stuff cleaned up. And it's the same thing, putting the hardware back in. We're just going to move our tensioner just a little bit so that way we can slide everything by hand, rather than fighting the bolt on the side of the bearing. Make sure our washers are set in place. And now that we have it set there, I'm going to move it to its far end limit and tighten it back down. And our cam gears will go back on. With our retaining bolts. So the key to getting the timing belts reinstalled back onto the engine while maintaining our camshaft timing is really ensuring that we have the belt in the correct tooth on the lower drive pulley and all the cam gears, and that we don't have any slack in there. Now it's especially important on the drive side of the belt and also in between the intake and camshaft gears. So we're just going to set the belt down here and kind of get it loosely started on the lower pulley. Doesn't really matter where you do it. I will say that I am a little picky on where I put my Ferrari font. I have it all in the same direction, but I picked somewhere easy to set the first part of the Ferrari, so that way when I do bank 2, I can make them match. Not totally necessary, but that is just my own thing. So now I'm wrapping the belt around the pulley and just getting it started really, so that way I can be sure that it's seated in all the teeth down here on the lower drive. And you can see that I have just far too much slack up here. So I'm gonna see if I can rotate that pulley and move it a tooth essentially. And now it's seated all the way on the lower drive. You can see right here, this is the drive side and it's pretty tight. We're seated all the way into our exhaust cam gear. And I already had to move this intake cam gear a little bit to get this to line up, but you can see that it's sitting all the way on the intake cam gear as well. And we have enough slack to actually slide the belt over. And now we can just slide it right back on. We're going to expect to see the slack here because we've done nothing with our tensioner. So that's where all of the slack that we should have. There should be no slack right here on this belt, no slack right here. That's how we know we can ensure that it's back to where it needs to be. Now I mentioned it that I already had to move the intake cam a little bit, so I had to loosen these cam caps up top here, use my 27mm wrench, and just kind of move the camshaft just a little bit. I actually had to take the camshaft and advance it, so I had to rotate it towards me in order to make these the pulley line up with the belt. Now if you need to make a movement on a camshaft like I did to get the belt on, it should be fairly obvious on how far the alignment or misalignment is in between the tooth and the gear. Usually you can see that the tooth is favoring one of the valleys of the gear, so you know that you just have to make a very small adjustment on the camshaft. I mean, back here on our assembly marks on the camshaft of the cam cap, it barely made a movement. You just want to do it just enough to get that belt to snap on. And once that belt goes in and in the grooves all the way around the gear, you then will have enough slack in the belt to get it around the tensioner bearing. So I'm going to work to get the other belt installed real quick, and then we're going to start talking about getting them tensioned. All right, so our timing belts are on. We're tight on our drive side, we're tight between our gears, and we're very loose over here because we still have our tensioners backed all the way off. We haven't released the bolt on them to have the spring bring them back in. Same thing over here on bank 2. You can see we're tight up there. I also had to move bank 2 a little bit on the intake side, but you can still see that our assembly marks, for the most part, are still lining up. Again, I can't stress enough that those, in my opinion, are not very accurate, because if you have a tolerance of plus or minus 1 degree on the camshaft on your timing, you're not going to see that on that mark. You can move that 1 or 2 degrees, even more, and you're not going to see enough change, and it's debatable where that mark lines up. So we'll revisit those once we're done timing the camshafts in, but we're just making note of where they are now. The next step is we need to work to get the timing belts tensioned. However, if you recall, all of our cams are locked in position with our business cards, and we also have our flywheel lock on the engine. So I like to loosen all those things up or take them off. So I like to take the flywheel lock off, loosen up our cam caps. At this point, we can take the business cards out. We don't need those right now. I will get that all taken care of. I'll get these out. We'll get our flywheel lock off. Now, before I take the flywheel lock off, I do want to take a second and reinstall our crank pulley. Now, if you guys saw the video where I went and resealed this front timing gear drive, you'll see that there's a helical gear that's driven off of the camshaft, and that crank pulley is critical for holding that in position. If I'm rotating the engine over and I don't have the crank pulley on the outside diameter, holding this race in, holding that gear can walk forward, which would radically change our camshaft timing, and it would just make us chase our tail. So I'm just going to take advantage, since the crankshaft is in its locked position, where I can slide the pulley on, I can tighten the bolt, then take off my flywheel lock, my business carts, my camshafts, so that way the engine's free to rotate over. Before I do so, I'm going to jump ahead and show you guys the balancer and my degree wheel. So I have this all set up from when I did my camshaft timing check on disassembly. Unfortunately, I have not been able to get a extra harmonic balancer for a 456 550 of this belt-driven V12. So I can't make a fixture like I have for the 355 where I can use my big 16-inch wheel and bolt it directly into the balancer. I'm using the customer's balancer in this case, and this is the one that came off of the car. I'm using this small Mr. Gasket degree wheel. Again, I like the bigger degree wheels, but this is what I have, and I've used this for years. But I'm looking to improve my setup, so I'm keeping an eye out for an extra balancer, so that way I can modify it, make my tool work. But it's pretty simple. You can see I have 4 bolts. I drilled a perimeter pattern that fits the pulley, and you can see I just use the bolt with some big washers, and it actually fits pretty good and stays pretty tight. You can't really over tighten them, you just get them pretty hand tight, and that's there. And you can see that I've gone and drilled out this center hole. I'll grab my socket for this socket right here, and that is so it fits nice and tight in there, the driver crank bolt. I like this method because my degree wheel is attached to the harmonic balancer, which that is keyed to the crankshaft, and this degree wheel is tight enough on there where it's not going to move or rotate, and my tool is basically separate from the degree wheel. So all my force that I'm using to rotate the engine over is going into the bolt, which goes into the base of the balancer through a keyway, and I'm not driving the degree wheel, so I don't have to worry about the degree wheel slipping on my balancer. So this is my solution. Like I said, this is probably the most economical solution if you're looking to get a degree wheel attached to your car using your factory balancer. Now, while we have the balancer here, there's one more thing that we do need to talk about, and that is the rubber membrane that holds the inner hub to the outer ring. I briefly mentioned it when we were doing our inspection on the car, but this rubber will start to give over time. It starts to crack and deteriorate, and this outer ring can separate from the inner hub. I've seen that where it can actually go backwards into the plastic covers, go through the timing belts, and you can have a pretty big repair bill on your hands if you lose your timing belts. So what you want to look for is you want to look for cracking in there on the rubber. Now it's deceptive because if you look here, it looks like there's a lot of cracking, but that's actually, like right there is extra rubber that's part of the casting that's sticking out, but a lot of this is actually paint. So they make this balancer and then they paint over this rubber. Then over time, that paint starts to flake off, separate from the balancer, and that flaking paint can actually end up looking like a cracking rubber on the balancer. I mentioned it during the inspection. When the balancer is installed in the car, we can use a mirror and we can make an inspection of that rubber ring. But really, because of the paint and how hard it is to see, when you have the balancer off, you need to give it a good inspection on both the front and back side. Make sure you don't have any cracking on there, because, I mean, again, if you see any signs of anything that is telling you that rubber is compromised, it's aging, it's fatiguing, get the balancer rebuilt or replaced. So there are companies out there that will rebuild these, or you can install a new part, whichever is your preference, but it is one extra check that you need to make, and it's critical once you get the balancer off the engine. All right, so we have all of our business cards out. I have my flywheel lock off. So now we're just gonna go and we're loosening the bolt that's holding the tensioners, and the springs are gonna pull them back into the belt a little bit. There we go. On to the next step. Now the reason why I chose that order to take the flywheel lock off, my business cards out, then release this bolt, is because I want the crankshaft and the camshafts free to move, so that way when the tensioner starts to act on the timing belt, I can be sure that all the slack is taken out here, and all the slack that I may have up here between my cam gears and on the drive side gets taken out. Not that that spring's strong enough to move everything, but I don't want that stuff set and locked in position, because then I release this tensioner. It's going to take the tension out in between the crank drive here and the intake cam, but if there's slack here or here, it won't be able to do anything about it. That's my method, and you can see that I've left the bolts loose, so we're just relying on the spring to pull the tensioner back to get the tension out. Now let's talk about how you set the tension on this 456. The workshop manual gives us 2 separate ways to set the tension in 2 separate areas of the manual. And if any of you have read in on the early Ferrari workshop manuals, honestly, I'll say any workshop manual from Ferrari, but the ones of this era with the 456, they're a very rough translation. They're very literal, so you really have to read them and try to understand what they're saying, because it doesn't really make a lot of sense when it's translated to English. But one of them basically tells us to get the engine in the state we have now. We have the camshafts in, the belts on, the tensioners on and loose. Then it tells us to rotate the engine in the direction of rotation. watch for the maximum travel on the tensioner. At that point, stop, tighten the bolt, and we're set. I don't use that method. It's very arbitrary and you don't know where you're setting it at, and there's no tangible way to measure it. Now, in a separate part of the workshop manual, there is a second method that it gives us to set our timing belt tensions, and that requires the use of this, which is a mechanical deflection gauge for the timing belts. It's called a Stager. This gauge is also commonly used in the Porsche and Volvo world. I believe the Porsche part number is 9201. I'm not sure if these are still available. You can find them floating around on eBay. I'll warn you, they're very expensive. Getting one of these used, I've seen prices range anywhere from $400 to $900. And if you do get one of these, you have to get the calibration bar with it as well. The workshop manual carves out the Stager gauge, and it gives us a spec of 135. But that spec that it's giving us is actually the sum of the two belt runs. So it's the sum of the deflection on this run and the sum of the deflection here on this run. So we would take this gauge, set it up on there, measure our deflection, add the two numbers up, and I think the spec is 130 to 140. Seems pretty simple, right? Except I think for most of us that are doing this at home as a do-it-yourself, that tool is far outside of our price point and it's not justifiable. However, there's also another problem. I held this up over here on bank 1, and you can see we have all the space we need to get the tool on. You come over here on bank 2, and we're good on the long run, but right here, there's not a chance in the world I'm getting this tool on this lower run. Our bracketry for our power steering pump is in the way, and I'd have to go through and remove all of that just to check my belt tension with that Stager gauge. It doesn't have a lot going for it, and I can tell you that that gauge, I find it harder to set the timing belt tension with that gauge because your numbers between adjustments don't seem so consistent. So it's time for some interesting Ferrari trivia here. The timing belts on this 456 GT are actually the same belts that are used in the 456M. Also, they are used on the 550, 575, and 612. All of the belt-driven V12 Ferraris use the same timing belts. However, the method that Ferrari gives us to tension the timing belts changes from car to car to car, although it's the exact same part number of timing belt. Another little odd fact as well is the factory recommendation for these timing belts, the service interval, Ferrari says every 3 years. On the later cars, the 575, with the exact same belt, Ferrari then changed it to every 5 years. And I think they may have changed it to every 6 on the 612. I don't remember for sure. They obviously are doing some pretty interesting things with changing things around with keeping the same belt. We can use that information to our advantage. So on the later cars like the 575 and the 612, the way that we tension the timing belts on the car is with a belt frequency gauge. This is an optical belt frequency gauge. So we'll use that gauge, we'll hold it up to the belt, we'll strike the belt, and it's actually using a sensor to measure the frequency that that belt is moving at, and that's what we set the belt tension to. Now that helps us overcome the problem with our power steering pump bracket being in the way, and I can tell you that that is the method that I do prefer because it is the quickest, it's the easiest, and it's the most consistent and repeatable method that I've used. Now also one of the biggest benefits of this frequency gauge is it's probably the easiest and most achievable way for you guys at home to set your timing belt tension. Now if you guys jump back in my playlist and check out the 355 major service that I did, I actually spent some time setting my timing belt tension on that car, and I actually went through the mechanical procedure that Ferrari gave us. I compared it to the Stager. I compared it to the frequency gauge. I also went and compared that to the Gates Tension Right app that I had on my phone. And I compared that Tension Right app, which is using the microphone in the phone to measure the frequency of the belt, versus my gauge, which is an optical gauge. And I can tell you that this particular gauge right here is incredibly expensive. It's much more expensive than, say, the Stager gauge. And I wanted to see how accurate the phone app was to my very high-end gauge. And this is an optical gauge, so this is using like an infrared sensor that actually watched the movement of the belt, where my iPhone was using the microphone to measure the sound of the belt moving. And I can tell you that they were both pretty much exactly the same reading. If you guys want to check out that video, check it out because it was a pretty interesting experiment. I say that because it's going to be the easiest way for you guys at home to set your timing belt tension. You don't have to invest in a lot of tools. You already have the phone. The app is free. You can download it and use it. The one rub with that is if we look in the workshop manual for this 456, there is no reference for what frequency we should set the timing belt tension to. We only have specs for the Stager gauge. Now, we could use deductive reasoning and take the specs that it has for the 575 and the 612. However, some people might not be comfortable with that, and they might really prefer to have a specific number that's called out by Ferrari to set the timing belt tension on the 456, or say if you want to use the frequency gauge on a 550 as well. However, there's a little known bulletin that Ferrari released, which is bulletin 1016. It was released years ago. The purpose of that bulletin is to actually give us the specifications that we need to set the timing belt tension with a frequency gauge. But really what's more important on that bulletin is it actually gives us for each car a breakdown of what the tension should be with a stagger gauge, and then right below it the conversion to the frequency gauge. This bulletin covers, I'm going off memory here, I think it covers 360, 355, I think it covers 348, I know it says Testarossa, and it covers 456, but also in the 456 section it mentions 550, 575, 612. However, if we go in the workshop manual for the later cars, it already gives us that spec for the frequency gauge. So really this bulletin is giving us an outstanding reference, the cross-reference, what the stagger spec should be to the frequency gauge, and it really covers all of the cars that we need to that have timing belts. So you're going to have specs called out for your Testarossa, which is the same as your 512 and your 512M. Obviously, we have all derivatives of the belt-driven V12s, 355s, 360s. So that really eliminates the problem of not having the specific frequency called out in the 456 workshop manual. Since the bulletin calls out both the spec for the stagger and our frequency gauge, it's actually a pretty great resource because I can reference it back to our workshop manual, and the bulletin matches the workshop manual. It's saying 135 for both runs with our stagger. I know if it's calling out the same spec in the stagger as it is in the workshop manual, then I can trust the spec it's giving me for the frequency gauge. What we're going to do is I'm going to take the engine and I'm going to rotate it over a couple times in the direction of rotation. I'm going to stop it at top dead center, and then I'm going to let it sit for a little bit because we're going to be running the belts. They're going to stretch a little bit. I want everything to stabilize. Then I'm going to come back. I'm going to show you how we're going to take our measurement with our frequency gauge. We're going to make some adjustments and work to get our belt tension dialed in. Now there's an important thing to keep in mind when we're setting our timing belt tension, and that is that we want the engine in the exact same position each time we check the tension, so that way our readings are consistent from each time we make any changes after we rotate the engine over. For myself, my preferred method to do so is I just check the engine with it at top dead center. It is by far the easiest position to place the engine in, to be able to get it back there to be consistent with it. We already have a degree wheel on the harmonic balancer from when we checked the timing beforehand, and you can see that I put on my coat hangers here, or my timing pointers, so that way I know where top dead center of bank 1 is, and since it's a 65 degree V12, 65 degrees over is where I have my other pointer for bank 2. Now these aren't calibrated because we had everything off, I just put them back on, but they're going to be good enough for us now to just to stop the engine. We'll be within 1 or 2 degrees of top dead center. This set our belt tension, and then once we get into degreeing the camshafts, I'll show you guys the method I use to make sure that these are calibrated to the degree wheel in relation to the piston movement. We're lined up top dead center 1 here, so we're going to rotate it over 2 revolutions, which is going to be 1 revolution of our camshaft, and then we're going to stop the engine and check our belt tension. Right there. Now normally I say I like to let the belts stabilize before we check the tension on them, and I usually wait 2 minutes each time, but from my past experience what this tells me is our belts are going to be too loose right now, so then we're going to have to tighten them anyways before we actually get our adjustments. The main thing I was trying to achieve by rotating the engine there was to make sure that I had all the slack out of the belts before we get into the procedure. For good measure, we'll check anyways, so we'll turn our gauge on and we're going to measure that. The short run is 143. And we're 125 on the long run. So that puts us at about 260, and our spec here is 335 to 360 hertz. Naturally, we have a ways to go, and we're going to need to tighten the belt up. To tighten the belt, I'll just use a screwdriver right here. You can place it right in between the water pump and this ear that sticks off of the tensioner, and we can just take that and gently push the tensioner in. You can see it move slightly there on the belt. Now we're going to come back, put our wrench on, and we're going to snug down this tensioner bolt so it doesn't move. We're going to rotate our engine 2 revolutions. We're going to wait 2 minutes, and we'll reread the tension. All right, and we will wait 2 minutes. Okay, our 2 minutes are up, so we're going to check our tension. We'll start here on the short run, and we're at 262 hertz. And on our long one, we're at 165. So the spec of 335 and 360, we're about roughly 70 hertz too tight now. We're going to make another adjustment on our tensioner. We're going to take it away from the belt a little bit, tighten it back down, rotate the engine over 2 revolutions, wait 2 minutes and recheck. And it's really wash, rinse, repeat until we hit the spec that we need. So I'm putting just a little bit of tension there so we don't lose the adjustment we made. And we're just going to loosen that up a little bit. Allow it to move just a little. And tighten it back down. And rotate the engine. Now we need the weight. That's 266. 168. So again, we're still too tight. So I think you guys get a pretty good idea of how to set this tension. It's really a lot of the wash, rinse, repeat of what we've done. We need to go through, check our tension, make any adjustments that we need to on our tensioner, rotate the engine over, being sure that we stop in the same position each time, wait for our belt to stabilize, pull our measurements again, and see if we made it within the range that Ferrari gives us. If not, make an adjustment, either tighter or looser. And it's really wash, rinse, repeat. So I'm going to just continue to repeat this process until I get bank 1 set to the specifications we need. I'm going to focus on getting that taken care of. Then I'm going to shift my attention and get bank 2 taken care of. And once I'm done with that, I'll bring you guys back and I'll just give you a rough recap. I'll probably let you know how much time I ended up spending getting them set where they need to be, because sometimes you can get this belt tension set and spec really quick and it doesn't take very long. And there's other times where it feels like you just chase your tail forever. I'm going to get focused on that and I'll see you guys back here in a second. All right, so Murphy's Law got me on this one, guys. I was planning on walking you guys through the process to set the timing belt tension, but after I made the first couple of adjustments, I was like, I'm not sure if we're going to get it quickly, and this might get a little boring. So I set you guys aside, and that's where I just went and focused on it real quick. As soon as I turned the camera off, moved it aside, guess what? I made one adjustment on bank 1, got it in spec. And I was like, all right, well, maybe bank 2 will be harder. So I moved the bank 2. I made 2 adjustments, got it in spec. So pretty fortunate that we were able to get it in spec that quickly. I wish I could have just kept the camera rolling so that way I could show you guys the process all the way through. But I knew that if I would have kept the camera rolling, it would have never went that way and it would have took forever. It was kind of like a lose-lose for me. However, they're both set, and I think I said the spec was 335 to 360. Look at my notes here. Yeah, 335 to 360, and I ended up setting both of them to 340 hertz total for both runs. Now that we have our belts on and tensioned, we need to focus our attention to calibrating our pointers on our degree wheel. So I just kind of eyeballed them on there, and they're not calibrated precisely to where we can actually trust our degrees. It's only, giving us a rough ballpark. The way that we're going to do that is we're going to be using the piston, because there's a couple caveats to this. I don't rotate engines counterclockwise, or I should say I don't rotate an engine in the opposite direction of its normal rotation. With a timing belt engine, you run the risk of jumping a tooth on your timing belt. There's other engines that have other issues with the drive gears or oil pumps. So it's just kind of like a rule 101 for me. I don't rotate them backwards. Now I'm saying this because one of the quickest and best methods for finding true top dead center is using a piston stop, and then you would rotate the crankshaft, stop the piston before it's at full top dead center, then turn your direction the opposite way, rotate it again. Each time you're at the piston stop, you notate where you're at on your degree wheel and your pointer. You add those 2 numbers up, divide it by 2. That's your top dead center. So that method is really quick and easy, but generally that really only works best if you have a cylinder head off the engine and you know like what you have in the engine in terms of like drive gears for oil pumps like we mentioned. So since we have belts on and the heads are on, I can't use that method. We all know that as the piston comes up, it actually dwells for a couple degrees at top dead center. I'm really picky and I want to try to get true top dead center and account for the dwell. So how are we going to do that if I can only rotate the engine clockwise? I mentioned earlier we're going to use a top dead center piston stop. So we have this adapter that goes into the spark plug hole here. So I'm going to have to run this in. And I will say that you want to make sure that this is tight. You don't want to leave it loose. I always make a habit to just snug it in with a wrench like that. Because again, everything we're doing here is about precision and being precise. So we have that locked in on cylinder 1. We have our appropriate rod on our dial indicator. We're just going to slide that in. When I set this dial indicator up, I will say like right now, I am close to the top dead center. That's one thing to keep in mind, because when I set the depth of this dial indicator, I typically, like this is bottomed out all the way right here. I actually will lift it up. Fidelity on this thing's crazy, so you have to be real small with your movements. I'll rotate it like that so my main needle is pointing straight up. I always do that because it just makes it a lot easier for me to take a glance of where I'm at in my position, because this face rotates so we can zero it. And if I have the needle at an obscure angle, it just makes it harder to read. So I just make it easier on myself, and let's say I'd bring this gauge up and lock it in right there at 0 for our top dead center. So that's really step number 1, but I need to set you guys down to get this gauge positioned. So I'm gonna do that. I'll bring you right back. Okay, so we have our dial gauge in, and you can see I have it pointing upright and zeroed it out. One thing to keep in mind, if the set screw that holds our dial indicator in, sometimes if you tighten this down too much, it will actually bind your shaft here, and you won't be able to follow the movement of the piston precisely and accurately. It'll kind of get bound up, and that'll cause you to chase your tail. I'll also just kind of give it a couple little drops here, just to make sure that we return back to 0 and that we have easy, consistent, repeatable readings. So we have that. We have our degree wheel down here with our pointers, and we're roughly at top dead center. You have to be real careful at the angle you look at. You can see I overshot it a little. And this other one we're not going to worry about right now so much, but we will adjust this to 65 degrees once we have this one established and calibrated. The method I use to calibrate my degree wheel and my pointers to my TDC gauge is really a modified version of using a piston stop. So if you think about using a piston stop on an engine where you're limiting the travel of the piston going up, and then you rotate the other direction, limit the travel of the piston at the same point, and then you measure those 2 points and divide it in half. What I'm doing is essentially the same thing, except I'm not rotating the engine backwards, and I'm not limiting the travel of the piston. So what we're going to do is we're going to be watching our piston travel gauge. We're going to stop the engine at the same piston travel coming down on our compression stroke and coming up on our compression stroke. Each time we're going to stop at that position, we're going to check our degree wheel and our pointer. We should be at the same degree before and after top dead center at that piston movement. Now, I'll show you guys when you run through this procedure, because we will kind of have to refine our pointers, and sometimes you have to make some changes to your TDC gauge. So anytime you change either gauge, you need to run back through and make sure you're accurate. So it's kind of a game of rotating the engine over, calibrating our pointers and degree wheel, calibrating our gauge, pointers and degree wheel, until I have consistent, repetitive readings on them. Now, another important thing to note is that when you're calibrating this gauge and your degree wheel, be sure that you're doing it on the same engine cycle. I always do mine on top dead center compression. I do so because, believe it or not, the fidelity on our TDC gauge is so fine that when you're rotating the engine over on compression, since we have the spark plug hole semi-plugged, there is a little bit of room around the brass bushing for this tooling for air to come out. But we do build a little bit of compression. It actually pushes down on the piston. You'll actually see some of the bearing clearance in this gauge, meaning if I rotate it over 1 revolution and I'm on top dead center overlap, the zeroing point of this gauge won't be accurate until I rotate it 1 more time and bring it back to top dead center compression, and then it returns to 0. It's actually pretty wild to see that much fidelity, but you just want to be sure that you're consistent, so that way each time you do it, it's repetitive and you can repeat the process every time. So I'm going to get you guys set up, and we're going to get this degree wheel calibrated. All right, so I have everything set up, and I think you guys at home actually have a really great view of the degree wheel and our TDC gauge. We have everything set, just kind of eyeballed to top dead center. We're not going to make any adjustments on the first revolution. We're just going to kind of make some data gathering. Really, I want to make sure that this TDC gauge is as close as I can get just visually before I start moving my pointers on the degree wheel. So we're just going to bring the engine around 2 revolutions, back over to top dead center on our compression stroke, and we're going to stop a little shy before we get the top dead center. We're not going to bring it all the way up right away. We're at 20 degrees, 10 degrees. So now that I'm at 10 degrees, I'm just going to stop, and I'm going to watch my TDC gauge, and I'm just watching the movement of the needle in relation to its 0 point. I want to see, okay, I'm at 0, so I'm looking at my degree wheel, and I'm probably at maybe half a degree before top dead center. But I want to see if this needle overshoots our 0 point, and I'm kind of want to watch its dead dwell point in relation to the degree wheel. So it looks like it's pretty well at 0, maybe just a hair off. So we'll just move our gauge face a little, and we're right at top dead center. See, oh, looks like we overshot that a little. There we go. And now we're falling down past top dead center, and our needle is moving. So we're pretty close from where we're starting at. So now, as the piston's coming down below top dead center, we're going to stop at 0.5 millimeter on this gauge and then reference what our degree wheel says. So we're watching our TDC gauge only. And we're slowly moving this engine over, coming up on 1/2 mil. And we're going to stop right there, dropping down, looking, and I'm right at about 9 degrees. So with that, I'm going to move my pointer and get it as close as I can, right between 8 and 9 degrees on the degree wheel. So that's signifying 8.5 degrees. That's pretty good. So then we're just going to rotate this engine over. 2 more revolutions. Right now that's telling me everything's calibrated, but we're going to confirm that. So then we're going to look at our TDC gauge again. We're going to watch it as we bring it up. It's getting close to 0, so we're kind of check our degree wheel. We're getting close to top dead center. I just hit 0. I just hit top dead center, and it dwelled, and it's starting to come down already. And we're moving past top dead center, so everything's looking really nice. We're watching our TDC gauge now. The piston's moving down, so we're stopping at 1/2 millimeter on the down travel. Right there, we check our needle again, and it's in between the 8 and the 9, so we're at 8.5 degrees. So now we know that this gauge is calibrated, showing our true top dead center, and we know we have our pointer on the degree wheel showing true top dead center. So you guys can see that process went pretty quick. However, I do have the benefit of having a lot of experience with this. It's really just trial and error, and there is a little bit of feel to it. Whatever number you pick on your TDC gauge, you just need to correlate to what you are going to be getting on your degree wheel. I could set this up at 1 millimeter of piston travel, and it's just going to change my degrees here that I see on the degree wheel. That's the number I use, and I've just always used it ever since, and it's worked really great. If you wanted to have the piston move further before you take the measurement on your degree wheel, you sure could. It's whatever works for you. But what we're doing is we're really just making sure that we're measuring the piston at the exact same point on its way down as it is on its way up. So we know the middle point of that is our true top dead center. Once we know that we have our TDC gauge set, it's stopping at 0, and we come back to our degree wheel, and we can really use both of those 2 items to verify each other or establish their calibration. Meaning, if I'm wildly off on this TDC gauge, I'm not going to be able to get consistent numbers on my degree wheel. If I'm off on my degree wheel, it's going to show up on the TDC gauge. Now, I will say sometimes you do need to adjust the face of the TDC gauge to re-zero it out when you're at top dead center, so you're kind of recalibrating that gauge. Now, when you have to make an adjustment here, you need to come back and just verify everything on your degree wheel. So if you make any adjustment here and we move that, that's changing where we're effectively measuring our piston and this calibration of our degree wheel. Sometimes it's kind of like a little bit of back and forth game where you need to make sure that this is zeroed out, and you might refine the face of this gauge as you're rotating the engine over, and you're also going to be refining your degree wheel and your pointers. And eventually you're going to get to a point where neither one of them needs any adjustments or movement. You're going to have everything locked in, and you know that it's now calibrated. Now, I will openly admit that the fidelity or the precision that I'm calibrating my crankshaft to top dead center on is very fine, and some would argue overkill. Again, I like to do everything as precise as I possibly can. I like to go about it doing it in a way that is repetitive, consistent, and gives me the same results time and time again. So I am just here showing you guys the methods that I have learned and kind of developed over the years. They've worked really well for me all the way up to this point, and I plan on continuing to use them and find ways to refine them. Now that we have bank 1 calibrated, is what I will do is once I have the engine rotated back over, I can look at my degree wheel. I'll make sure I stop at top dead center with this pointer, and then I'll just come over here and I'll manually move bank 2 to 65 degrees on the degree wheel. Can't really do it now because we passed top dead center, but I'll just kind of manually move it because I know that it's a 65 degree engine. Get this pointer calibrated, and then I'll just leave everything as is. And then I'll focus on doing all my cam timing over here on bank 1. Once I'm finished doing my cam timing on bank 1, I'll move this TDC gauge over into cylinder 12 on bank 2. I'll go through this process to recalibrate it, but it's going to be a lot quicker because I've essentially already calibrated my pointer at this step. I've seen it where some people will put one pointer on the engine, they'll calibrate that pointer over here on bank 1, they'll move the gauge over to bank 2, and they'll actually loosen the degree wheel, move it on the crank hub, tighten it back up, and then go through this process again to recalibrate the degree wheel and the pointer. If you notice, I position my degree wheel and my pointers in a way where I can have them both on at the same time. I can read them both. And I do this so that way I don't have to mess with my degree wheel at all. So once I move over the bank 2, I'm only spot checking my pointer, making sure that nothing's moved and it is calibrated correctly, but it's usually just confirming that it's already set correctly because we set it here. So that's really one of the things that I've done over the years. I didn't always used to do that. I used to actually move my degree wheel, and then, you know, over time I was thinking like, man, I'm wasting time moving my degree wheel and get everything set back up. There has to be an easier and better way to do this. And that's the method where I finally realized I should just put 2 pointers on, calibrate them both at the same time, and then verify the second pointer's calibration when we move the bank too. So it's time to get into the camshaft timing. So far up to this point on the channel, I've only been able to walk you through a timing belt service on a 355, and there is some differences in what we're going to be doing here on this 456 compared to that 355. Now, those differences aren't so much because it's a 355 and a 456. It really comes down to the lifter type. So the 355 has hydraulic lifters. This 456 is mechanical lifters. Ferrari gives us two different techniques on checking the camshaft timing and where they're degreed in, depending if the car is a mechanical lifter car or a hydraulic lifter car. The jump over to the 355 that we've already shown on the channel, when we are measuring those camshafts to get them degreed in, we are actually measuring the movement of the lifter bucket, and we are actually looking for a specific called out movement. Say it was like 2.41 millimeters. So we would be watching our dial indicator gauge, watching that lifter bucket move to that specified millimeter of travel, and then we would check our degree wheel, and we would have essentially what I consider an arbitrary number on the degree wheel that we needed to have that number correspond to. If we were looking for 2.41 millimeters on the intake camshaft, then we were looking for, it was like 16 degrees on the degree wheel of crankshaft movement, and that told us where our camshaft was degreed into. It's a bit unusual because you're not actually watching the actual intake and opening of the valves. You're going past that point and then making a measurement. I will say that the numbers that they give us on hydraulic lifter cars, it will change from car to car to car. It's not a consistent number across the board. It's a little bit different versus what we do on the solid lifter cars. Now, on the solid lifter cars, I say it's a bit more conventional because we're actually watching the exact point of opening and closing of the valves in relation to the degree wheel. In my brain, it's more relatable to exactly what the camshaft is doing. On the 355, I use an additional dial indicator. This is my setup where I bolt this onto the head, I get it adjusted. I have my little welding rod there at the bottom so it bends under the camshaft onto the lifter bucket. And this is what I use to watch the movement of the lifter bucket, which is giving me that, the example I gave, the 2.41 millimeters of movement, so I can check my degree wheel. I will say that the workshop manual does say to set up tooling like this on a solid lifter car like we have here at this 456, so we can watch the bucket travel and see that movement while we're checking our camshaft timing. However, I do not use that. The reason being is because when the camshaft's starting to open and close, when you're watching that dial gauge, it's really hard to have a definitive point of when the camshaft's opening or closing because the ramp angle is so shallow on its initial movement or closing that gauge kind of bounces around a little bit from 0, the 1, the negative, and it's really hard to identify when the true opening or closing point is. That's kind of the benefit when we're measuring with the hydraulic lifter style, where you're watching that gauge move and we're looking for 2.41 millimeters, meaning we've already moved 2 millimeters in the travel, so we're on the really aggressive part of the ramp where you're moving, and your crankshaft movements are very linear with the movements of your dial indicator, versus when you're trying to catch right on the heel of the ramp, you can move the crankshaft a couple degrees and you'll be questioning what numbers are correct and not correct. The way that I measure if my valves are opening or closing is I actually use this small pick, and if we look right inside the valve right here, we have that little opening right there. So I'll actually just run my pick and I just gently work the lifter bucket just like so as I'm rotating the engine over, and once this lobe starts to apply pressure to that bucket, it's an instant stop. It'll stop and I won't be able to spin it anymore, and then I'll just check the degree wheel and I see what degree I'm at. Now if I'm measuring when a valve is opening, I put this in there and I just hold a little bit of pressure on the lifter bucket and it won't move at all because the cam lobe is applying pressure to it. Once that cam lobe releases pressure, it's going to spin and I just stop my rotation, check my degree wheel. This method is actually a lot easier because I don't need to watch two things at once. So when we're using a dial gauge on our camshaft and our lifter bucket, I have to bounce back and forth and look at my degree wheel, look at my dial gauge, degree wheel, dial gauge, kind of like when we're setting our TDC gauge up and calibrating that. Using this method, I can get this set up on the lifter bucket, apply a little pressure or wiggle the lifter depending if we're opening or closing the valve, and then I can just focus all of my attention to the degree wheel. I can rotate the engine very slowly, watching my numbers. Once I feel this move, I stop, and I can read my marks on the degree wheel, and that tells me where my camshaft timing is at. Much easier method, and I'll show you it in action here in a second. Now, as for the specifications on this, Ferrari gives you the camshaft timing specifications, but it doesn't really tell you like what numbers you're looking for like we had in that 355. So you can see that I pulled down the numbers, and you have to keep in mind Again, we have these all shimmed at 0.5 millimeter. So if you don't have these shimmed at 0.5 millimeter, or you're not that accurate with how you shimmed them, these numbers will be inaccurate and your camshaft timing will be off. So with everything shimmed at 0.5 millimeter, it gives us our intake valve is opening 6 degrees before top dead center and closing 54 degrees after bottom dead center. Our exhaust cam is opening 54 degrees before bottom dead center and closing at 10 degrees after top dead center. Now you're going to see that I have my intake opening and my exhaust closing highlighted, and you can see I have them emphasized here at the bottom. Now if you guys know a lot about camshafts and valve events, really the most critical events are your intake opening and your exhaust closing. Those have the greatest effect on how a car runs, performance, drivability, power. Those two events, it's really your valve overlap. Yes, your intake closing and exhaust opening also have an effect on the power of the car, but it's not as significant as your intake opening, exhaust closing. So when I'm degreeing in the camshafts in the car, that's what I'm focusing on. I'm focusing purely when my intake valve opens and when my exhaust valve closes on my overlap. So that's why I just highlight this there. So when I'm degreeing the engine in, I make it quick and easy to make a reference. So our intake opening is 6 degrees before top dead center, and our exhaust closing is 10 degrees after top dead center. Those are the main numbers that we're going to focus on while we degree in our camshafts. So I'm going to get you guys dropped in there, and we're going to start running through our camshaft timing, see where it's at now, and see what adjustments we will or will not have to make. Okay, so we're going to start with our intake camshaft over here on bank 1, and you can see we're on top dead center on overlap. So right now we cannot move the lifter bucket on our intake valve at all. On this, we're actually watching the intake opening, so we've actually overshot it on our engine rotation. So we'll just go and work to bring our crankshaft around. Now we have the lobe off of the lifter bucket, so you can see we can now move it. So I'm going to rotate it, just get a little closer before we start checking our movement. And I can kind of glance at my degree wheel and see when I'm kind of close. I'm at 45 degrees before top dead center. Looking at our spec, we're going to open at 6 degrees. We can rotate this probably up into the 10 degree range, right about there. And now we're going to jump over and start to check the movement of our lifter. So I just kind of get in a comfortable position where I just keep wiggling it. And then I focus all my attention to the degree wheel until I feel this lifter stop. Right there, it stopped. I have no more movement, and I'm at about, I'm going to give that 5 degrees before top dead center. So on our intake camshaft, we are opening at 5 degrees before top dead center. Our specification is 6 degrees before top dead center, but it does give us a plus or minus 1 degree tolerance. So we are within spec, and looking back at my notes on disassembly, I was at 5 degrees before top dead center on bank 1 intake camshaft. So really, I have everything back exactly where it was from disassembly, which is a great sign. Now the V12 cars actually have a tremendous amount of fidelity in our camshaft timing adjustment, so we can go through the procedure to make the changes we need to get that cam timing exactly to open at 6 degrees before top dead center. But before we dive real deep into that, I think we're going to jump over to the exhaust cam. We're going to see where the exhaust cam is closing at and compare it to our specifications and see what we need to do to get bank 1 within spec. Our exhaust cam, we're looking to open 10 degrees after top dead center. Right now, that's going to be the same cycle essentially, so we're at 5 degrees. So it's roughly going to be 15 degrees of crankshaft rotation from where we're at, so we're very close to make that check. Again, I come over here on this bottom side because I have more room. I don't have to work around the cam lobe. And again, the exhaust is closed, so I can't move it. And I just apply a little bit of consistent pressure on it. My eyes go to my degree wheel, and we wait until the lifter bucket moves. Should be getting close. Right there, it moved right there. And looking at our degree wheel, I'm gonna say that is right at about 9.5 degrees. Once again, our spec is 10 degrees. Our tolerance is plus or minus 1 degree. On our exhaust side, on disassembly, before we did our timing belts, I was at 9 degrees after top dead center. So we have everything exactly back to where it was, and that's what I would expect because we marked our cam gears, our dowel pins, all the location of everything, and we reassembled it back to how we took it apart. This is a great example of why it's worth the effort to mark everything like that and get it back together, because we're already this close on our camshaft timing. So if we decide to refine our camshaft timing and try to get it exactly on specs, it really saves us a lot of time in the long run. So there's one more thing that's worth noting, and that's with this procedure I just ran through real quick. I only went and ran through it one time on the intake camshaft and one time on the exhaust camshaft. When I'm going through and setting the camshaft timing and get everything set up where I want it to be at, I generally look for 3 consistent readings. So meaning I'm gonna go through this cycle 3 times individually, and I need the readings to repeat each other each time. So I'm gonna have to come back up on 5 degrees on my intake cam, 9 degrees on the exhaust cam, and keep getting the same readings. If I start having my readings change in between, I need to find out why they're inconsistent. Really, the key is don't rely on just one reading. Even a good example now, I read both camshafts. They're both within our 1 degree tolerance. And I could just say, yeah, it's great, and I could move on. It's wise of me to at least run this engine through a couple more cycles and confirm the data I have. You don't want to rely just on one data point. So you need as many data points as you feel comfortable with, run back through the cycle. If I get the same thing each and every time, 3 times, at that point, I generally say, okay, we're good. I can move on. So let's run through and make a couple more checks and verify where we're at on our timing. We're coming in on intake opening. We're at about 20 degrees right now. Coming up on 5. And right there, we stopped. And that's right at, really, I'm reading 5.5 degrees on this one. So one advantage we can do here on this method is we can immediately jump over, since we're right at top dead center. We've already checked the intake. I read 5 degrees the first time. The second time I read 5.5. We'll jump over to the exhaust and we can get on there. And we don't have to rotate the engine over through a whole nother cycle to get the exhaust measured. We can just measure it when it goes to open right here. So we're putting pressure on it. And there it is where it opens. And again, that's right at 9 degrees. So if we can retard that cam a little bit with some play in our dowel pin, it would help us out a little. See if we can't get this moved. Come back around to the intake again. Got to fight that plastic cover a little bit. So we're 30 degrees. We're well in advance. We're coming up on 10. And that's actually right at 4.5 there on that time. Move over to our exhaust. And exhaust, we're at 9.5. And give her one more. And we're at 5.5 again. And 9.5 degrees. So that's pretty consistent. It fluctuated a little bit, but I keep coming back at 5.5 on the intake and 9.5 on the exhaust, which is half a degree out. Okay, so our spec on this car that Ferrari gives us is plus or minus 1 degree, and we are actually better than that. We are only half a degree off on both camshafts. I will say that the adjustability that Ferrari gives us on these cam gears and camshafts on the V12s is very different than what we have on the V8s. These are almost infinitely adjustable on the way that they're set up. Meaning if we really wanted to invest the time to both pull the timing belt off, make changes to our cam gears, reinstall the timing belt, retension the timing belt, mathematically, we could get those camshafts degreed exactly on spec. That could turn out to be a lot of work if we start going down that route. So I'm going to hold off on that for now, and what the plan is I'm going to move all my tooling over to bank 2, and I'm going to check the cams on bank 2. What I'm hoping for, honestly, is I'm hoping for something that's quite a bit further out of spec, where we're going to have to be going through that procedure to even just get it in spec, because it's a lot more justifiable for me to have a camshaft that's 1 or 2 degrees out and go through that work to get it dialed in the spec, than to go through and try to refine these camshafts by half of a degree. It's really a cost first benefit scenario. The amount of time it's going to take me to try to refine that to a half degree to what I'm going to gain for it on the long run, it's really, really hard to justify, because I could end up spending a couple hours, 2, 3, 4 hours on that, and everything's pretty much dialed in right now. We're well within Ferrari specs. Like I said, I'm going to move my tooling over to bank 2. We're going to make our checks. Honestly, I'm kind of hoping one of the camshafts out so I can show you guys the procedure. but we won't know until we get everything tooled up and measure it. All right, so I got my TDC gauge moved over the bank 2. I already went through and recalibrated the TDC gauge and our pointer and our degree wheel, and I did actually have to move it just a little bit, maybe half of a degree, to get everything centered and where it needs to be. So we have that established. We know everything's set and calibrated, and it's time to run through and check and see where the bank 2 camshafts are degreed in at. Really, it's going to be the exact same thing as we did on bank 1. So we're going to bring it over and get to the intake opening. And we're using this pointer now, not the second pointer. So I'm watching, I'm going to stop right there at about 15 degrees. Get my tool up on my lifter bucket, and I have movement. And we're going to slowly rotate the crank until it stops. Again, we're looking for 6. Getting close. And it stopped right there. And I'll move my wrench so you guys can see that's right at 6 degrees. So that's encouraging. That's really good. Let's now jump to our exhaust. And we got our tool on there. Our exhaust is closed, so we have no movement. And we're looking for 10 degrees after top dead center. So I'm just leaving a little bit of pressure on the exhaust. Turning the crank, getting close. Right there. And that's right at about 9.5 degrees, which our spec is 10 degrees. So the way things are looking, our bank 2 is dialed in just as accurately as bank 1. So we're going to go run through, do some more checks, and be sure that the numbers we just got are accurate. That stopped right there. That one was right on 6. 6 degrees, right on the money. And that one's right about 9.5. So we'll do it one more time. Okay, stopping at 10 degrees, 4 top dead center on the intake. Once again, 6 degrees, so we know the intake cam, bank 2, dialed dead nuts on spec. Move over to our exhaust. Right there, again, 9.5, so we can trust those numbers. Excellent. All right, so we have our camshafts back where they were when we disassembled it. All 4 of them are dead nuts in spec. Half a degree, and our tolerance is plus or minus 1 degree. Honestly, that half a degree, it's so finite. I just really, like we said on bank 1, I can't justify tearing the belts off, making the changes, retensioning the belts, rechecking the cam timing, moving my dowel pins, and going through that process for only half a degree. I could really end up spending half of the afternoon doing that, and I really just honestly don't think there's that much there to get on half of a degree. There is one more thing that I didn't really mention, and that's when we first put the timing belt drive gears on, I left our cam gear bolts loose on it, and then we rotated the engine over in the direction of rotation. I do that purposely because that loads the camshafts essentially in the most retarded position with that dowel pin on the cam gear. When I did the service on the 355, I actually talked about it where you can actually loosen this cam gear drive bolt, and you actually have maybe about a degree of slop in between the dowel pin, the hole in the cam gear, and the hole in the camshaft, where you can actually make really finite changes with your cam gear and your camshaft without changing the location of the dowel pin in the hole. However, I only will do that essentially in the retarded position because that's the direction of load. If I were to advance the camshaft in that position and then tighten the bolt down, theoretically the camshafts could still rotate in the retarded position because of the way and the force of the timing belt trying to rotate the cam gear and the resistance of the camshaft and the valves. Therefore, theoretically, it could rotate back into that retarded position and my cam timing would be out of spec. So by leaving those bolts loose, the rotating the engine, the direction of rotation, then tightening them, it just ensures that my camshafts are loaded in the retard position, which is the natural load of the rotation of the engine. You can do the same thing by putting a wrench on your cam lobes and pushing the cam backwards and just getting rid of that slop. So what I'm trying to say is I will use that slop that's in the dowel pin to make fine changes to the camshaft without moving the dowel pin holes. However, I only do that to retard the camshaft. I don't do it to advance it because the potential for the cam to move back into that retarded position. You can also do the same thing by loosening the bolts, putting a wrench on the camshaft, pushing it in the retarded position. I like to do it that way because it really just eliminates any possibility of everything moving. So I got to tell you guys, this particular job is a small personal victory. I say this because I've had many cars that come in the shop. I do the pre-service cam timing checks and the cam timing's dead on spec. I can get the old belts removed, the new belts installed, recheck the cam timing, and I'm able to retain the camshaft timing even after removing the camshafts and get it all back together. I've done that many times. However, On this particular car, as I mentioned earlier, I removed, rebuilt, and resealed the front timing cover, and those front timing drive gears where they key into the crankshaft. I have never been able to get that done with those back in the same position and not have it radically alter my camshaft timing. I went about that repair in a completely different method on this car, specifically so that way I could get the timing back to where it was. And I'm pretty pumped because we just finished checking our camshaft timing, which confirms my entire theory that I was able to get all of that off, back on in the same position, and just a little bit of extra work and being meticulous and methodical on doing that repair. Some may think that it slows me down up front, but here on the tail end, saved me a heap of work with the camshaft timing. And for me, always looking to get a little bit better and improve my methods. So that's just a nice little win for me and a small personal victory. Even though we ended up not making any changes to our camshaft timing on this 456, where we didn't have to move the location of the cam gear or the dowel pin, I still want to take a minute and discuss it a little bit because there's really a lot to cover here. Now, I will say that I discussed this topic in great detail when I was doing the timing belt service on the 355. However, we can't just use that information because Ferrari changed stuff on us, and basically the specs and numbers and the theory of it changes from the V8 cars to the V12 cars. I will be referencing the 355 and what we're covering here because I'm kind of talking about the difference from what Ferrari did with the 355 or the V8 cars over here to the V12. This is the diagram out of the workshop manual for the 355, and I've highlighted these colors. So it's showing our camshaft gear here, and this up here is showing that our dowel pin holes are 24 degrees apart. This red line right here is indicating that the gear teeth are 11.25 degrees apart. This is our camshaft, and it's showing that the holes on our camshaft are 22.5 degrees apart. I explained this in the 355 series of videos, but essentially if we take the dowel pin out of a hole in the cam gear, we rotate the cam gear just a little bit, which is going to make two new holes align up with each other, and we're essentially going to move the dowel pin one hole forward in the camshaft and the cam gear, or backwards, depending on what movement we need. And that's effectively going to give us the difference of the 24 degrees to the 22.5 degrees, which is a 1.5 degrees of camshaft movement. That 1.5 degrees of camshaft movement correlates to 3 degrees of crankshaft movement. So essentially, when you're moving the dowel pin, you move it in the cam gear and the camshaft at the same time, and that's going to give you 3 degrees of crankshaft movement. So we can move our cam timing in 3-degree increments with that method. That is the same for a V12 car versus a V8 car. Nothing's changed there. However, there's some notable differences that we're going to talk about here between the V8 and the V12. So on the 355, our pitch of our teeth on our belt is different than the V12 cars. So our spread for our teeth on the gear is 11.25 degrees. Also to note, we do not have holes all the way around the circumference of the camshaft. So we'll jump over to the picture of the 456. Instantly, you can see that we have holes 360 degrees around the camshaft. Again, they're spaced the same at 22.5 degrees. So essentially, it's the same as this, except this one on the V8 cars is missing 2 holes. Now we come to our cam gear, and we can look again, 24 degrees. So I mentioned that the dowel spacing on the cam gear is the same between the V8 and the V12, and the spacing on the camshaft is the same, except we have more holes. Where it gets different is this difference in pitch. So you can see now we're at 13 degrees and 33 minutes on our tooth pitch versus the 11.25 over here on the V8 car. This radically changes everything because on the 355, we could take the cam gear off, move it to belt teeth, realign our dowel pins, and that essentially was giving us a 1.5 degrees of movement. Our main movement on the V8 car was 3 degrees by just moving the dowel pin inside the cam gear and camshaft. If we're to reposition our camshaft gear on our timing belt 2 teeth on the V8 cars and reposition our dowel pin, that gives us a 1.5 degrees of crankshaft movement. So that's how we get our finer fidelity. However, it has its limitations because as we make those changes, it radically moves the location of our dowel pin, and we can't just keep making infinite changes because we may run into a point where the dowel pin wants to sit in one of these empty spots. So I'd say the ability of adjustment that we have doesn't have as much fidelity on the V8 cars as the V12 cars. Now we look at the V12 car, we have the different pitch, which is going to change the mathematics of how far we move our cam timing by moving the timing belt in relation to the camshaft gear. And also, we're not bound by the constraints of having these blank spots in the camshaft. So we can essentially move the cam gear on the camshaft infinitely all the way around and in relation to the timing belt. So we can almost set this up in relation to the timing belt and the camshaft anywhere we want to go. We can just keep going in circles and changing things. To show you that, I made a little chart right here, And you can see that this is talking about moving the timing belt on the camshaft gear. So if we move the timing belt 1 tooth, that means we would effectively need to move the dowel pin 9 degrees, and that's going to net us 1/10 of a crankshaft degree of movement. So it changes a little bit here when we're looking at the second column. So if we're moving the cam gear on the timing belt 2 teeth, it's essentially saying to make the small adjustment that we want to see on our camshaft timing, we're going to need to move the dowel pin 18 holes. Well, there's only 15 on the cam gear, so I have this other column here basically saying, yep, you just move it 3 holes either direction depending on where you want to go. And that's going to give you 2/10 of a degree of movement at the crankshaft. With each tooth that we move our timing belt on our cam gear, this chart tells us how far we're going to have to move the dowel pin to get our cam timing back in spec. And you can see here, we essentially can change our cam timing in 1/10 of a degree at the crankshaft. And because we don't have the limitation with the blank holes here on the camshaft, that we have holes all the way around 360 degrees of the camshaft and the cam gear, this equation and numbers pretty much will go on forever. So that's where it's saying this V12 has more fidelity. So in the example on our 456 here where our cam timing was half a degree off, if we look at this chart and if I'm looking for half a degree at crankshaft movement, come over, that's saying that I need to move my cam gear on my timing belt 5 degrees. And right here, it's actually saying I need to move my dowel pin 45 holes. But since there's only 15 optional holes, that means my dowel pin would essentially stay in the same location. Now, the reason why I'm choosing not to go after that half a degree on this 456 is because that ends up being quite a bit of work. It sounds simple, but I would need to move this cam gear on this timing belt only 5 teeth. But I need to be sure that this timing belt stays in the exact same position on this cam gear and our crank drive. And once you take the tension off, this belt's want to flop around and move. So it takes some coordination and work to get everything back on in the position you want with the changes you need. And then naturally you have to go back through and retension your timing belt and then go through, check your cam timing, and then if it's not right, make any changes. A lot of times it's great, we have a chart, right? And it's all math, but when you put it in practice on the engine and check it, you didn't get the result you wanted, and you have to find out why. Did you miss a tooth? Did you miscount? Did things get misplaced? That's where I said it could end up taking a lot of time, especially if you're fighting the timing belt tension to get that set correctly. Since everything's set and it's so close in this car, we're just gonna let it be. I'm saying that because I know that I have more cars coming in, more timing belt services on the way. And I know eventually one of those cars that's coming in, the cam timing is bound to be pretty far out of spec. So we'll be able to work through that process at that time. But I just wanted to give you a quick crash course on the difference of the V12 cam timing as opposed to the V8 cam timing that we've already covered here on the channel. So I wanted to take a quick second and show you the reference marks back here on the camshafts on how, in my opinion, you can't trust them. You can see right here on the exhaust cam that it's not quite lined up, and the intake one looks not too shabby, but we'll come over here to bank 2 and take a peek here at the exhaust. You can see the exhaust is pretty decent. We can get up to the intake and see that that doesn't match at all. Again, I cannot stress enough, those marks that are on the cam caps and the camshafts are your general assembly marks. Even though 2 of my camshafts are half a crankshaft degree from spec, that's really a 1/4 of a degree at the camshaft, and you are not going to see that on those marks. But what I'm showing you guys here is proof that those marks are not that precise. So the people that say that you can pull your timing belts off, just align your camshafts to those marks, put the belts on, and not check your cam timing, that is something that I would never do because your cam timing could be out by quite a bit. It's one thing I like to check on every car when I do the cam timing just to see, and I can tell you that they do not line up. And even if you go through and make even 6-degree changes on your camshaft, you cannot really see it on those marks. If you're doing your own car, do what you're comfortable with. As for myself, I would never rely on those marks. So with the engine timed, what is next? Well, I need to get my timing equipment off the front of the balancer, take my pointers off of the engine. I need to get my flywheel lock back on underneath at the bell housing, and also go through and put my business cards back in, locking the camshafts in position. So I'm gonna get that taken care of, and I'll see you guys back here in a second. So we have our tooling in the bell housing, locking our flex plate and crankshaft in position. You can see that I have the business cards back on our camshafts, locking those in position. I already removed my degree wheel and my pointers. You'll notice that I pulled out the one bolt here on the camshaft, this retaining bolt right here, and that is because I replaced the O-ring that's on there. So you can see the old one, and they get pretty deformed with time, so I always replace these, but I always do so at the end of service, so that way I only put the bolt in once. I don't want to put on the new O-ring and then end up taking this bolt in and out as I'm making camshaft timing changes. So this is my preferred method to go about that route. And then while I have the bolt out, I also come back through here and I clean up my marks that I made where I was indicating where my dowel pin goes on the cam gear and the camshaft. Again, those oil paint pens work pretty good. You can just take a small pocket screwdriver, lightly hit it, it scrapes it right off. I even went and took off the other markings that were on the cam gear. This is what was on the intake cam. It had the same thing here on the exhaust. I cleaned all that up. I always mention it. I don't like leaving marks on the cam gear. I don't like leaving any indication that I was here. So I do these one at a time. I'm going to put this bolt back in. It gets torqued to 98 Newton meters. And then we'll come over to the intake side, clean up all of our marks, replace the O-ring, get those cleaned off, get the bolt torqued. We'll torque stripe our hardware. Same thing on bank 2. We're going to need to torque our tensioner bearings. Those are torqued to 56 Newton meters. Once I torque these, I do come back and just verify my timing belt tension, that it hasn't moved, since sometimes these can move on you a little bit when you're torquing them. So we do that. Also, crank bolt, right here. We got this guy, a little bit of blue Loctite. That's torqued to 216 Newton meters. And that's where our tooling that we made that's locking our flex plate in at the bell housing comes in key, so I can get that torqued. So I'm going to get all that stuff taken care of. Then we need to get our business cards out of our cam caps, take another pass torquing all of our cam caps, make sure they're all torqued to spec. And then we actually need to come back and address our shims up here in the front of the camshafts. We have those lashed to the timing spec, which is 0.5 millimeter. And we have the shims. We've already ran the valve adjustment beforehand, so I know what shims I need to put back in. I'll take out those 4 shims, put in the ones that were in there, double check my camshaft timing, and I'll think we'll be at that point. I'm going to get this stuff knocked out real quick, and I'll see you back here in a second. Okay, so we were able to run through, get all of our O-rings replaced, get everything torqued down, torque striped, cleaned all the marks off, got all our tooling off the engine, went through and took out our shims that we had set on the front cam lobes on both banks for our cam timing, that 0.5 millimeter clearance that we had, put them back to the running timing. And really, we just ran back through the engine and got it reconfigured and really set up for the reassembly process. Essentially now, since we have the new timing belts on, all of our seals replaced, the camshafts are degreed in, and the timing belts are tensioned, that means all the work that we need to do to the timing belts is actually done, and we're ready for reassembly of the engine. Well, I hope you guys picked up some tips and tricks on doing the timing belt service on this 456 here. Hopefully that'll help some of you guys out at home that are tackling this project on your own. Also, keep in mind, a lot of what we covered on this 456 is really going to apply to a lot of the later cars with the 550s, 575s, and 612s. Although there is differences between the services on each car, the basis and majority of what we did here will apply to those later cars. Naturally, when I get those later cars in the shop doing the belt services, I'll bring you guys back. We'll make videos. We'll talk about the differences and how they do the services on those later cars. Now, this particular timing belt service is a pretty rare example of a timing belt service, to tell you guys the truth. To have a car come in where all 4 camshafts are pretty much exactly on spec is pretty unusual. Add in the fact that I had this torn down so far, reassembled it, and was able to maintain all of our camshaft timing, and that they are still in spec where we didn't have to make any changes to get them within our 1 degree tolerance is very unusual. It's very unlikely. For me, it was excellent because I minimized the amount of time that I had invested in this belt service, and it's going to help me get through this car, everything completed much quicker, so I can move on to the next cars that I have waiting to come in the shop. However, I fully recognize that it doesn't make for the best content here on the channel, especially when I'm trying to walk you guys through the procedure of how to do it, when I tear it all the way down and put it back together and it's right where it needs to be. But that's just the situation that we had at this car, and well, honestly, I'm not complaining. Now, I will say I do have plenty of jobs lined up, and I do have more V12s coming in for timing belt services. So hopefully one of those cars, when they come in, we'll run through the cam timing, and hopefully we'll have to start getting into those changes, moving the dowel pins and cam gear on the timing belt. So that way I can walk you guys through that procedure in much more detail, and maybe your car is the next car that I have in the shop that I'm making these videos on. Alright guys, you know the drill. Be sure to like, share, and subscribe. Drop your comments below. As always, I greatly appreciate your support, and we'll see you on the next one.